And broadcast, it says we're live.
Today on the Workbench, it's the Ham Radio Workbench Roundtable. Stay tuned. Well, good evening, everybody. It's the Ham Radio Workbench podcast, and today we're going to do a live stream, and today's topic is all about what's on our workbench, and we have some great guests tonight to talk all about what is on our workbenches. So to start things off, let me welcome everybody who's listening and also who's watching on the live stream. Welcome to the Workbench. If this is the first time you've joined us, thanks very much for tuning in, and if you're a regular listener, thanks a lot for coming back. So a few things that we want to touch on in the beginning of the show. If you want to find out more info about the podcast, you can check out our website at hamradioworkbench.com. Follow us on Twitter with the handle hamworkbench. You can also leave us messages on our contact page on the website. You can connect with us on Facebook. Just go to Facebook and look for the group Ham Radio Workbench, and we have over 2,100 members on that Facebook page today. And a lot of folks post their projects, and we share what we're working on our benches. And you can also talk with us live and direct on Brandmeister Talk Group 31075 and now on the All-Star Link Network Node 55915. So with that out of the way, so today we have Mark N6MTS.
Hello, how are you doing?
Very good, Mark. Thanks for being here. Vince VE6LK.
Good evening. How's everybody tonight?
Everybody is good. I'll speak for the crowd. So we're all doing good. It's Friday
Great
night.
idea.
Yeah. And our special guest, Marcel AI6MS.
Good evening from sunny California.
Welcome. And Doug K6JEY.
Yeah, hi. I'm not really up in the woods. I'm down by my lab in Long Beach, California. Nice to be with everybody.
It does look very woodsy there in Long Beach.
Inordinately.
And Dennis W6DQ.
Good evening, and I'm coming to you live from the California high desert from my AM studio, amateur radio AM studio.
And we're looking forward to learning all about that tonight. So today's show is all about what's on our workbenches, and we're all going to talk a little bit about some of the projects we've got going on. And all of our special guests who are on the show today have been on before to talk about all kinds of interesting projects, from power systems and batteries to test equipment to moving the Voice of America transmitter to the East Coast and all kinds of crazy projects. So I'm sure there'll be a whole bunch of other things to talk about tonight. And a few things I do want to mention before we get into the roundtable. The Ham Radio Workbench product number 101, the DC Power Strip Kit, has been selling like crazy. And we have a whole bunch of them now back on DigiKey. And you can go to digikey.com and order your kit if you'd like. And we're also going to make plans for more kits coming up in the future. Also, we talked to our friends up at Digilent about the discount code for the Analog Discovery, and they're going to continue with the discount code into 2022, which is great. The discount code is changed. It is now Ham Radio Workbench 2022. Not like you couldn't figure that out. It wasn't.
Who didn't see that coming?
No, who would have thought that? And actually, that code is slightly better than the last one. I think it's up to 35% off on the bundle. So it's a little bit of an extra bump for those of you who want to buy the Analog Discovery 2. And we'll do more stuff on those devices, I'm sure, coming up in the year. So that's a little bit of the setup for tonight. We're just going to do a big roundtable discussion, and each one of us is going to take a turn and talk about some of the stuff that's on our workbench. And let's see, I think where I kind of want to start is tonight is with Marcel. I think we'll put you up first. We'll nominate you to be the first person in the first slot here, Marcel, to talk a little bit about what's on your workbench. What you working on?
Sure, George. Thanks. Yeah, no. Well, I was just showing our live stream audience the Ham Radio Workbench DC Power Strip kit that I have handily pulled off my workbench to have in front of the camera. Just got that one, I think, last week, and it will happen soon. In theory, we'll get that one running here pretty soon. But it's a nice little kit. It's got all the little parts in it. So if you haven't, it's now available, like George was saying. But yeah, no, my main workbench right now is busy mostly with Arden projects. So I've been doing a lot with a couple different Arden groups. So Arden, for those that don't know, is an amateur radio emergency data network. It's a 2.4 and 5 gigahertz wireless system that people use to connect with each other and use a higher speed data link. So instead of just a 1200 baud packet, we're doing other things. So most recently helping actually the Bayonet folks, which some of you are part of as well, get a node set up in the South Bay area in California, and have some folks be able to connect to a new 5.8 gigahertz node there. So that's been quite nice. And we're also helping out students down in San Luis Obispo at Cal Poly University get a couple nodes set up in the central coast of California. So I've been doing a lot of projects there and helping them out. So we prepped a little bit here. This is on my workbench. So right now I'm playing around with this nice little unit called a Ubiquity Solar Point, Sunmax Solar Point, which is an all-in-one charge controller and 100 megahertz or 100 megabit Ethernet switch with 4 ports. And this lets us power up little wireless nodes pretty easily. So this can just deploy out onto the network, and you can have little Ubiquity devices that are 24 volt PoE powered, just hooked up to it, and it does all your battery management and solar input control really, really nicely. So been doing some testing with that, and quite literally bench testing with power supplies and E-loads to try to figure out how to get all those pieces working and understand the capabilities of them and what kind of the limitations are. So that's kind of my initial pass at what I've been working on. Though the last year has been a lot of radio site projects, so we can get into those too if you like, unless you guys had some questions about that I can answer.
I do have a question.
Go ahead, Mark.
I heard recently, I don't remember exactly where, that there was a timeline put on the sunsetting of our access to the 3 gigahertz band. Do you know whether, like, how much of the networks that you are working on are using the 3 gig band?
Yeah, no, it's a great question. So for those that don't know, the FCC has been selling off spectrum to, for whatever reasons, making money is the common goal online. But yeah, the amateur radio band has been partially sold off. So people that have 3 gigahertz links are losing them. So George, I think that impacts your group as well, right? Do you want to talk about that briefly?
Yeah. So we have 2 repeater sites in the Bay Area, and before we put in the data network part, we started out by connecting them with a UHF full duplex analog FM point-to-point link. And so if you go into the repeater at our East Bay site or at the South Bay site, you'll come out both sites, and it's a full duplex 420 megahertz path. And that's still in place. That's the primary voice path. But what we wanted to do is augment that with a data path. And so we decided to do that on 3.4 gigs. And we've been using Ubiquity gear. Gosh, I think we installed that stuff about 6-7 years ago. It's been up there for quite a long time. And the path is a pretty reliable 10 plus megabit per second path without going too crazy. We have a couple of dishes, a dish on one end. I think it's dish on both sides of that path. And then we also had a sector panel antenna that was pointed towards the ground. So the idea was that you would go from the ground up to the repeater site on one 3.4 gig channel, and then we would link between the 2 sites in a different channel. And then at the other repeater site, you can go down to the ground on a third channel. And with the refarming of that 3.4 gig spectrum and losing a chunk of it, we had to move our radios into the part of the spectrum that we still are able to use. But what I don't know is if that's a temporary situation or if that's kind of permanent at this point. So as far as I know, they've taken away I don't know, half of the 3.4 spectrum we had access to, something on that scale, and we still have part of it to use. So right now we're staying in that band.
And what I've just posted into the chat log, and I'll put in the show notes, is the memo that came out from the ARRL on January the 18th, saying that the FCC released DA 22-39, and amateurs must cease operation between 3.45 and 3.5 gigahertz, excuse me. They must cease within 90 days of the public notice. That translates to April 14th, 2022.
But that's not the whole band. So
No, that's just a part of it, right?
yeah. So we just have to make sure we're not in that part of the band.
That's correct.
For some reason, I thought we were losing the whole band. We're only losing.
Well,
part of-
originally that was the threat. So this goes back about a year and a half ago
Okay.
when this first cropped up, and we were afraid we were going to lose the whole band. And I know the league made a big play to lobby to keep it. Dennis, are you familiar with that?
Yeah, I am, as a matter of fact, and Doug probably is too, since we're both microwavers. The piece that we are retaining, which is 3400 up to 3450, I believe, is on a secondary basis now. So we have to.
Gotcha.
Yeah, we're no longer a
nice.
primary user. We are secondary. Yeah.
Well, we're secondary in a whole lot of spectrum. So
yeah, we are. We are.
You know,
That's true.
that should be okay.
It should be. And hopefully they will allow us to remain as secondary users on that chunk of spectrum because of all the activity that we have there, the Arden and other things that are being done there.
And relative to commercial users, I mean, even though I think that there's a lot of potential for us and there's a lot of space there for us to operate, but compared to how congested it could be with commercial operations, we're probably a pretty light footprint. So I think we would be very compatible with whatever else they're going to put there.
Yeah, that's definitely the case. And I think a lot of those links that, like you talk about, the Bayonet link is currently running between two sites across with narrow beam width and, specific one channel that you're operating on. So if you look at the rest of the 3 gigahertz band in that Bay Area for amateur radio users, it's not particularly active or high usage. And that's probably part of the reason why they're okay selling it off and switching to, secondary usage.
And so we'd really like to use more of that. One of the things we found, by the way, is for point-to-point, it's great. So if you have an unobstructed view and you're not like trying to knife edge over a mountain or the earth because it's such a long path, it's great. But going from the ground to the hill on 3.4 gigs is pretty dicey. It's pretty dicey at 2. So the problem is that the radios are pretty low power. So your typical uplink radio is going to run 100 milliwatts or maybe a couple hundred milliwatts. Now you've got gain with the antenna, but if there's any clutter between you and the hilltop, like a tree, it really wreaks havoc with the path. And you really have to have a pretty clear optical path for it to be reliable. So the original reason we did this was to facilitate emergency communications in the Bay Area. If imagine there's a big event and you want to provide data communications, you want to be able to go anywhere in the Bay Area and pop up an access point. Basically, you want to pop up a local network and then have an uplink to the repeater site, which would then give you much greater coverage, at least on a private data network. And so that way you can run IP phones or you can run two-way radio backhaul or whatever you want. The problem is there's a lot of places where you might go where the coverage, even to the repeater site on 3 gigs, is pretty poor. So one of the things that we're also looking at is what are the other systems that we could use to augment that? So I think there's a couple things going on here. One is high bandwidth, high speed, but somewhat fragile paths, and then augment that with lower data rates, lower frequency, higher power systems like maybe D-Star DD mode, where it's tens of kilobits per second, but it's 1.2 gigs and it's 10 watts. There's a lot of you got 20 dB of advantage there or more. Or we also experimented quite a bit with NPR 70, which is using 433 megahertz, 10, 20 watt radios. But the data rates were also relatively modest. They were sub 100 kilohertz, kilobits, which is, by comparison to Wi-Fi, it seems slow, but you could send an email and you can send a text message and you're not going to do telephony over it, but
the internet was built on that stuff. So
yeah, good point.
Yeah.
This is ARPANET 2.0 40 years later.
Yeah, George, your comment about trees is very well taken. One of the challenges when we're deploying some of these new sites is exactly that, right? And a couple of the ones we've deployed recently, there are trees directly in front of the antennas that are blocking, if it's a 120 degree sector, but you have a tree in the middle that's knocking out 60 degrees of that, only your users on the edge can actually reach it unless they're flying a plane through the path. So that can get pretty challenging too. But chainsaw is going to help if you're doing fire mitigation, but has to, of course, be approved in those spots. So
Marcel, I'm curious, have you guys in the work you've done with I know you've done a lot of Wi-Fi wide area network projects. Have you looked at higher or lower frequency, higher power, lower data rate alternatives to kind of augment the Wi-Fi kind of stuff?
Yeah, so two things there. One is 900 megahertz band, which Ubiquity and other manufacturers do sell ISM band 900 megahertz equipment, but it's all end of life pretty much. So at this point, you're buying legacy equipment and trying to get up and running. A good amount of Arden does still run that. There are people that have those networks running. The other one would be, like you said, the NPR 70 modems. Those are the UHF 400 megahertz range radios that are higher power, but they're very low data rate, like you said, 100 kilobits or less in that space. They are IP based, which is also nice, so they do integrate a lot nicer than like a regular packet modem would for 1200 baud VHF work. But that is a challenge, and I think it's one of the things that some of the groups are looking at is trying to see, hey, are there different ways that we can get these networks running on different types of links? But frequencies are a challenge, right? Higher frequency gets you better bandwidth, smaller antennas, smaller radios potentially, but there's the cost trade-off there as well from range and ability to punch through things. So you definitely can't go through trees very well with 5.8 and still maintain a good signal noise ratio. So that's definitely a challenge.
Yeah, I think if we can find some ways to combine, high data rate systems and more robust things together would be, I think, be really great. Dennis, I know you were doing a bunch of stuff in Wi-Fi networking in the amateur band, weren't you?
Oh, we were playing around with it here in our valley. We'd want to put up an Arden network here. Right now, we're relying, believe it or not, on WinLink on HF as our primary emergency communications path out of our valley. We're surrounded by mountains. We don't have any good repeater shots over to our county seat in Bakersfield. So it's a tough one for us. Even on VHF, we don't have a good path over there, like even on 2 meters voice. So we're looking at Arden within our valley for communications, and primarily using WinLink actually to support our served agencies, which are the Ridgecrest Regional Hospital and the police department here. So
WinLink on VHF.
Yeah, WinLink probably on 2 meters is what we're going to end up. But we've got access to a repeater site. One of our club members has given us access to his repeater site, and we've been talking. We just haven't, the pandemic shut down a lot of the stuff we were doing. But we've been talking about putting an Arden network in here and putting one of the nodes up on his mountaintop, and we think we'll get pretty good coverage of most of the valley from there. So it's using probably Ubiquity, the 2.4 gig Ubiquities, and possibly the 5.8 gig Ubiquities. That's what we're looking at.
You should try 3.4.
Nope.
There's probably no traffic where you are.
Yeah, that's probably true. Yeah, we do have a military base right next to us, so who knows?
Oh, good point.
What they're doing.
You might become the target without knowing it.
Yeah, I think for our listeners, it's probably worth kind of pointing out that the concept around these data networks is typically that you have kind of high-level sector sites. So that would be a site kind of like a cell phone tower that's up on a hilltop or somewhere that has like a repeater, better coverage of a larger area. And then the users would have their client radios connected at their house, something like a Ubiquity NanoStation or one of these Locos, this smaller radio here that I'm showing. These are a little older, so not as useful, but pretty small. And you can literally throw that on the side of your house and just have that hooked up to connect to that sector. Then to connect your sectors to each other, you'd often hook up point-to-point links similar to that 3.4 gig link between the repeater sites that George was talking about. But that allows you to connect those high-level sites to each other with backbones. So network topology and architecture is kind of important when you're thinking about how to design these, how to do those interconnects, what sort of bands to use. Sometimes you might choose not to use amateur bands for those sector interconnects, if you will, for those backbones, because you can get higher data bits, higher data rates with stock firmware running on some of these radios as well, not necessarily switching to the Arden firmware, where you're then limited to amateur radio frequencies or amateur radio rules and regulations, of course, right? So Part 97, you can't do the encryption. You need to stick. Right now, they're only supporting 802.11n, so they're working on AC support, but that lowers your available bandwidth quite a bit if you're trying to do more like video streaming between different sectors or live webcam views. Those require a lot more data bandwidth, especially if you have multiple streams running simultaneously. So putting in like a gigabit backhaul between two of your sites with a commercial firmware running just, Ubiquity's AirMax or MikroTik's interface, that would be a very effective way to get higher bandwidth between those locations.
So going back to that router you were showing us on the screen a moment ago, you mentioned that it's got a solar charge controller built into the router case itself. Is that right?
Yeah. So it's the Ubiquity Sunmax Solar Point, and they make a small rack mount version of this as well. I only discovered this one recently. One of my friends deployed it at their ranch to hook up, but it's really slick. So it actually comes with standard MC4 connectors, which hooks up to your solar panels, and they accept quite a range, I think up to 60 volts input and around 10 amps or so. Don't quote me on those numbers, but it runs off a 24-volt battery system. So those of my YouTube followers, they would possibly recognize this battery bank that I had built a while back. This is a 7S10P lithium battery pack that natively runs in the kind of 24-volt range. So it's 21 to 29 volts, which I can then use natively with this. The firmware supports different top of charge voltages, so you can select what kind of battery, what capacity you're using. The setup's actually really, really nice. So you go through and set like the solar panel size, you set your location so it can do all sorts of planning for you. If it has internet connection, it can help do weather prediction. And then it measures the current on each of your ports. So you have 4 PoE ports that you can control with passive PoE 24-volt output. And then you also have an additional 24-volt DC out. So if you want to power an additional device like a floodlight or a webcam or a weather station or something else, you have those options. And that's all controllable by the interface with different priorities as well for, if it knows that there's going to be a storm coming up and your battery hasn't been fully charged, you can have it turn off lower priority devices. So if you have like a camera that you don't care about, but you want to keep the backlink up and running, you can have it prioritize those different features. So that's the sort of stuff I'm playing with right now, just to kind of understand what we'd want to use. We're about to deploy one locally, just as kind of a test to see how we can use one of these off grid, right, with just a 100-watt solar panel and a battery pack on a hillside, and have it be a little relay site. Yes, Vince.
Hey, Marcel, so on that Ubiquity widget is a highly technical term, mostly because I forgot what you called it. The white thing you were just holding up, the solar widget thing.
Sunmax Solar Point. Yep.
Thank you. You had 2 sets of power poles, I noticed. And one of them was red and black, and the other one was blue and white. So I'm curious why they're different.
So I'm doing what I tell people not to do here. For my bench testing, since all my E-loads and power is all like power pole interfaces,
Sure.
I'm running 24 volts on power pole, which I'm doing very carefully and only on my bench setup. I would never do this in the field, never,
Right.
ever. You'll actually notice my battery pack itself is running XT60 interface, so that's very intentional that I don't have a power pole in my battery pack that has more than 12 volts on it.
Right.
On the MC4s as well, I just used some jumpers again because my benchtop setup's running power poles, and this one, I happen to have a pack of different colored ones, so I made that one white and blue just to be different. My 60-volt bench power supply is also orange and black, so that I remember when I'm plugging that in that it can be different, right? I'm often using it at 12 volts. But not always. And this is also a 24-volt out, which is currently power pole, but again, only because I'm doing bench testing. For a field deployment, there would be no power poles on this system unless they're in a non-standard configuration. So either stacking them or doing a 3-pair and having them be offset so the center pin is empty. Those are the sorts of things you can do to make sure that you can't plug things in wrong in the field. The last thing I want is having power poles on that system and then some excited amateur radio operator that comes to the site and goes, oh, great, there's a charged battery here that I can plug my mobile radio into, and zap, that one will be gone very quickly.
Yeah, that would be a bad thing. A lot of people don't realize that power poles are incredibly configurable, and they can be set up to go top over bottom, side over side. They come in different colors. We're just so accustomed to seeing the black and the reds that we forget about all the other colors, right? So anyway, I just thought I'd point that out to folks in case they missed that nuance.
I saw a cool application of that. I think it was on the Buddy Pole Power Buddy Mini thingy. You know, they have a solar charge controller. It's really very nice. And I think the solar input to that thing is like yellow and black, so that, you know, you could accidentally plug in the wrong thing. And actually it's all 12 volts. It probably wouldn't bother it. But just to make it even clearer, you can see the socket you're going into is yellow, not red. So it was nice to see that little touch.
Yeah, and there are also different sizes of power poles. So one of my battery packs has an SB50 Anderson power pole, which is a larger 50 amp variant. And that can also be used if you're very intentionally trying to do something different. Vince, like you said, we're all pretty used to amateur radio with the Aries standard of that red and black power pole that can be anywhere from 15 to 45 amp rated, depending on the crimps that are used inside.
Yep.
That's kind of our standard. We expect a voltage range there that's, you know, 13.8 volts plus or minus 15, so it's compatible with our mobile radios. But you have to be careful that you don't misuse that. And I've been very particular. I've been deploying more and more 24 volt sites in the last couple of years, as a lot of IP based things are either 24 or 48 volts, with passive and active PoE. So that's been really critical. I've been using almost no regular Anderson power pole configurations for those deployments.
Yeah, very good. Okay.
All right. Anything else on the bench there, Marcel?
The bench is currently getting set up again. I've got a new office configuration, so everything's been moving around. So it right now is a little bit low on my test equipment, but it's kind of slowly working out the things that are important. You'll notice that my service monitor is critical. That one comes out first, and big power supplies is really largely what I've been spending a lot of time on. And then the regular multimeters that hang up on the corner, and pulled out my oscilloscope the other day, actually, which I hadn't used in a long time. For whatever reason, but occasionally you need that for things.
Your bench is irritatingly clean.
Yes. I did also clean off the surface because I had someone come by and do some testing, so I needed to have a little bit more space and clean some things up. So I have been helping friends with some projects as well. Yeah.
Can confirm his service monitor works well.
Excellent. Very good. All right. Hey, let's rotate over to Doug. Doug, I know you don't have too many things going on these days, so maybe you can let us know what's happening at the K6JEY lab.
Okay, thank you very much. I'm going to talk about two things really, and it's about new technology, stuff that's changed fairly recently in terms of radio and test equipment. And the first two things are Tweezer LCR meters. And the second thing is QRP rigs, because there's something brewing out there that I think you might find interesting. Okay, what I would like to do is get my document camera working. Is there a way to do that? I've got it plugged into the USB port. I've got the program going. Do I use share, and that'll bring up the document camera? If not,
what do you think?
I think what you'll need to do, Doug, you can either bring it up on another screen and hit share screen, or you can go into the gear right beside it and change your live camera.
Where it says cam
stroke mic down at the bottom of the screen. That's right. So for those people who are listening to this podcast, we are playing with StreamYard tonight, and we are live video streaming. And so this is kind of new to us. We don't profess to be.
So if you want to see what Marcel's workbench really does look like, you can go back and look at the video, and
yes,
be very jealous at both the cleanliness and the equipment.
Hey, surplus benches are amazing because you get to choose how strong and big and heavy they are if you get a good one. So.
And that's a real workbench. I wanted to ask you, what's the while we're waiting for Doug, what is the spectrum analyzer that you had on the bench?
Yeah, so in the middle of my workbench, that's my pride and joy. That's actually like the biggest piece of test equipment I ever bought, which is my RF service monitor. So that's a HP 8920B, which is, and for those that don't know what a service monitor is, it's pretty much an all-in-one RF communications test set. So typically these were used for cell phone base stations in the past, but a lot of them work in amateur bands. So this one does VHF and UHF, which is where I spend most of my time, and some HF as well. And you can test everything from transmitter deviation, power output, receiver sensitivity. Some of them have tracking generators built in, so you can actually do some S21 parameter measurements, measure filters, tune duplexers. Super useful piece of test equipment. Doug spends a lot of time talking about these as well, but this one, I bought many years ago at Halted in the Bay Area in Sunnyvale, and that's been my pride and joy. That's the one that stays on my bench. It's actually calibrated, or it was 5 years ago, and that's unusual in the ham space as well to actually have calibrated test equipment at one point. So
What's the unit on the upper shelf?
the upper shelf is a Rodian Schwartz digital oscilloscope, an RTV
that's a
2004. Yeah, that one I
I'm
was
ready. I'm ready to go.
fortunate enough to get from the DesignCon conference from the Rodian Schwartz booth. I won it when I dropped off a business card at their booth. So that was
wow.
yeah, I was
Oh,
very
right.
happy to receive that, and it replaced my analog scope, my 2465 Tech, which is gorgeous.
And they looked at you and said, "You don't look like Vince V6LK, but we'll let you have it anyway, right?"
Exactly. Yeah, they were very confused why I wasn't Canadian.
Oh,
You
my.
won it when they looked the other way.
Okay.
Excellent. All right, Doug, what do you got for
I'm
us?
gonna give up on the document camera, and I'm just going to put stuff in front of you. But I need to see my face. Okay. So there's you may have seen these. These are tweezers, and it has an LCR meter in the end of it.
Built
and
into the tweezer itself.
It's DT 71. They're about $80, and they're only 3 digits, so they're only accurate to about 1%. But they do LCR and voltage to 48 volts, and diodes. And the really cool thing about it is that they aren't regular tweezers. They're magnetic tweezers. These have no elasticity of themselves, but there's a repelling set of magnets in the back and an attracting set of magnets in the front. And so the feel of these things is that the amount of pressure needed to close the tips is consistent. Because in regular tweezers, you have to squeeze harder and harder to get the tips together. And when you do that, you can't feel what you're doing quite as easily. These are only good to things that are more than 0.6 of a millimeter. If it's smaller than 0.6 of a millimeter, you probably won't be able to pick it up.
But
That
you
means-
probably inhale it if it was smaller than 0.6 of a millimeter.
Yeah.
So do you use those things to?
Let me go on. There's a couple other things. The
Okay.
batteries in here are rechargeable. The head comes off, and the batteries are in the tweezers, and that's where you plug it in to recharge it. And this is all the circuitry, all the LCR circuitry in the computer and whatnot. It's auto ranging, the whole business. A
That's
complete
crazy.
LCR meter inside the tweezers.
So I got a question for you. If you have a discrete part and you clip on with the tweezer, I could guess how that would work. And by the way, that's obviously very cool LCR meter. If you're going to probe on a component in a circuit, how accurate is the measurement given that it's in amongst a bunch of other circuitry?
Okay, if you're going to do that, go to a DE 5000 LCR meter. And I've had that in one of the talks I did on test equipment. It's a multimeter size critter. It's 4-wire, so that means the wires from the meter go out to the test points, and the cables don't enter into the measurement. And that one will do 1/100 of an ohm, which is nice, and it will do ESR measurements, equivalent series resistance, and that's what you use for capacitors. You can have a circuit that's that you turned off, and you can go through it with the ESR function on the LCR meter and measure each capacitor in circuit. Okay. Now, if the other thing to work on is shorts. So if you've got a rail that's shorted out, you take the DE 5000 and you put it on the ohms setting, and it'll measure to 1/100 of an ohm. So you stick the minus lead on the ground, and you take the positive lead and run it across the rail, and wherever the resistance nulls out, that's where your short is. And you haven't unsoldered a darn thing.
Isn't that clever?
Very
So
clever.
I was always concerned when you're probing for like part values in a circuit that all the other components, of course, depends on the circuit, would have some effect. I mean, obviously, if you've got 4 capacitors in parallel and you measure one, you're getting all 4. But there's always like some odd combination of resistors, capacitors, and whatnot.
Tracing out the resistance. Now, with tantalum capacitors, it's easy. You just look for the one that exploded. I had my telescope out in Owens Valley Radio Observatory. That was the good news. And that was also the good news. There was no bad news because my Meade LX200 blew up. And I thought, oh, crap, I'm out of business. I can't, no astronomy tonight. The chief engineer at Owens Valley Radio Observatory came up and says, what happened? I said, it blew up. He goes, well, heck, let's bring it into the shop. Well, they build radio telescopes there, so they have a hell of a shop. And we went in there and we found out we blew out the input electrolytic capacitor, and we sniffed around and literally looked at it, like Wayne Yoshida said about doing non-testing troubleshooting. He says the tantalum's busted. Here, I'll get one. He doubled the size of the input capacitor and put a new tantalum in. I was back on the air with a telescope in a half an hour. If I'd have been out at some other spot doing astronomy, still would have been. Anyway, let me go on. This is the
Doug,
second
that radio observatory is just south on this map. This is Lake Crowley, so it's just north of there.
Oh, okay. I'm basically the outreach coordinator.
Exactly, it's wonderful. It's a great spot. Really cool to drive by that as well. If you
And
haven't been out there.
we did. Dennis and I did EME on their 40-meter dish on 1296 and 10 gigahertz. And the biggest, besides working everybody in the world, was that two other people found fallow dishes, one in Netherlands and one in Japan, and got them on the air for a period of time. So it had quite an effect. Okay, here's the second LCR meter. The first one was about $80. This is about $160, but it's got 4 digits. It's accurate to 0.2% on all 3 values, LC and R. And when you put the little goodies together, you get a reading. And it's accurate, easy to find, easy to read. The trouble is they're the pressure type of tweezers. So what you do is you pretend you're a little kid eating in Japan, and you choke up on the chopsticks right up in front, and you don't have quite as much pressure. But compared to the two, this takes more pressure to close. And as you put more pressure on it, you can't feel as easily. And I'm a guitar player, so I'm quite sensitive to how much pressure it takes. Anyway, but these are twice as good and stronger than the little ones, but they're also twice as much money.
And those will measure inductance as well as resistance and capacitance?
These are inductance, resistance, and capacity among whatever range you'd want to do. And you can use big stuff. You just cram it on the big stuff and it works.
So I see that also the tips, of course, are metal. Do you have to be really careful you don't touch the metal part when you're using that?
They're gold plated, so they don't corrode very easily.
No, I mean that you might
affect the
put
reading.
some straight capacitance on there or something.
No, not on capacity. It would be more on resistance, I think, and not on inductance. Mostly on resistance.
Okay.
If your
Depends
fingers
on-
aren't sweaty, the skin to skin is about 100 kilo ohms. So anything that's about 100 kilo ohms in parallel, if it'll affect that, then
Okay.
it'll
It
have
depends
an
on how nervous you are working on that project.
Yeah.
And then
so
you become a big bleeder resistor, not in a good way.
Yeah. I have a question for you, Doug.
Okay.
To represent all the southpaws in our audience,
Oh, yes.
is there a way to turn the screen upside down?
Yes, in both of them. The little
Done.
one, the little one does it automatically. It senses which way you have the tweezers set up.
Oh, that's brilliant.
It's
Oh,
got
wow.
automatic right and left, and this one has you set it for right and left. So you just go to the
Okay.
menu and go click, click, and it's left-handed. And us lefties can read it. That was the first thing I checked out.
Oh, you're a lefty too.
Oh yeah,
Perfect.
We have-
okay.
I'm a lefty
We have
too.
an abnormally high
I'm
population
so
of
lefty.
lefties here.
I'm so left-handed that I write better Chinese and Greek than I do English.
Okay. Yeah, that makes sense. Yeah.
Okay, thing number 3, moving right along.
Yep.
Here's a calibration box. Some genius little guy in China figured out the box, and then he got some nice mylar capacitors and some metal film resistors and made a coil, and then he got some really good test equipment and calibrated it. So you can buy this for like $25, and it's a Cal Lab in the box. It's got a nice resistor read out to 5 digits, a nice coil at 10 kilohertz, read out to 5 digits, and a nice capacitor at 10 kilohertz, read out to 5 digits. And they're so stable that once he makes the measurement, referenced against the standards he has, this will stay that way with these 2 LCR meters until your grandkids get a hold of it. I mean, it's a good, for $25, this is the best thing in calibration for DMMs and for LCR meters.
So when you got your tweezers, did you hook the tweezers to that to see if they're reading accurately?
Oh, of course, yeah. And they were
did it?
within the 7100, the little cool tweezer one is only accurate to 1% because it's only got 3 digits. So it's spec'd to 1%. So it read that pretty easily. The other one is 0.2%, and that was within spec on CLMR at that one value I checked. So it's pretty cool. Okay, that's LCRs. I'm moving along because you said we only had 20 minutes. Okay, so we do have 20 minutes.
All right, we have 1.5 acres this day.
Okay, the next thing I want to talk about is QRP rigs. And I can blame this on George.
You're welcome.
Oh, here's a kit for you. It's a
I blame so much on George.
A QDX QRP Labs kit. I said, oh, great. It's little. I can get it together in no time at all. Well, the good news was that all the surface mount stuff had been done, but I had to wind 7 or 8 coils, and I'm still not done with it. But I found something out that dawned on me finally this afternoon, and I made George change the notes. Because the talk is really about changes in technology. Extra features don't take extra circuits. And I'll walk you through how this happened. The QCX is a fairly big radio made by QRP Labs. And it's almost all through-hole parts. And the guy made it big so that people could buy it for $50 or $40 and play with the insides and change things with it. The only thing that doesn't get changed too much is the 16-pin IC that's got the programming in it. But it's basically a single band. This is a 40-meter 5-watt QRP transceiver, and it's really very nice. It's got a pretty big display on it, and the buttons and everything do what it's supposed to do. It's got lots of features, a keyer in it, and a bread maker. No, it doesn't have a bread maker. A keyer in it, and some other stuff. So it's a very satisfactory QRP rig, although these days a little bit big. So
to be fair, that's the QCX Plus that you just held up, which is the largest of the version. The original QCX was a lot smaller than that, and he's making the QCX Mini now.
We'll get to that.
Okay. Sorry. My apologies.
This is a little longer story, and George is still the progenitor of this problem. Okay, what he did, the two things he did do that were really interesting was he made the final amplifiers class E. So they're 80 or 90% efficient and dissipate almost no heat. So you've got 4 little transistors that are clumped on the board that do the output, and the input to that final section, I think, is a driver IC, a little tiny driver IC, and the PLL is what generates the signal. So the entire transmitter is basically the little 4 transistors and an SI 525 or something PLL and a TCXO. All of these have
5351.
5351. These all have TCXOs in them, vastly simplifying the transmit side. On the receiver side, he uses a filter and a Talo mixer, the same mixer that Elecraft K3 uses. So it's a pretty bulletproof front end, and it goes to an IQ output, which he combines in order to get single sideband and CW, and it goes into audio and out the back end. A very simple, extremely effective circuit. But that's just the start of the story. The second level, and you're seeing how I'm going down this black hole. This is the Mini. Same band, same specs, same receiver and transmitter, except it's all surface mount. Comes as a kit. All the surface mount parts are already done for you. You go back, you have to do the coils and a couple of through-hole parts. But this is a 5-watt radio that runs the same as the other one does, but you can put it in your shirt pocket. And I've made contacts on it. It's a cool little radio for a QRP rig. And I started with a Hot Water 7. Mm-hmm. This is a big change because it's all surface mount, and you can see what it does to size.
Well, yeah, although Doug, you have to admit that it does not offer the same microphonic capability that the HW7 did.
Because HW7 would go FM. You just pick the box up and say, "Oh,
you could send CW by tapping the box with your knuckles."
Oh,
anyway, I digress.
I lived in North Dakota with that thing. I had a dipole up, and I worked Brazil on 15 meters. That was exciting. Okay, so there, having gone that far, Hans, the guy's name that invented these, sends you the kit for $50. He'll build it for another 40. You can get a case for it. It's a very inexpensive way to get you or somebody else on the air. It reminds me of some of the projects that AWRL has had, like in the 80s, 70s or 80s. We had like a Tuna Tin 2 project. Okay, and that's a really good functioning radio with a good front end and simple circuitry. Okay, I don't have the QDX because it's still on the bench. It's even smaller. And they did something that's extraordinary. They took out the audio section and they put in a codec, modem from digital or to the USB port. So the QDX is only meant to do one thing, FT8. So all the control circuitry is out of the radio and in FT8. You plug it into the USB port, bring up WSJT, and WSJT runs the radio completely. There's no intermediate program of having to run the radio. WSJT runs the radio, helps you with the contacts, and does the logging all in one box. And it's a tiny box. The only thing on the box is an LED, and it tells you what you need to know and nothing else. So I've been asking the question for quite a while of what's the next step given the popularity of FT8 and other digital modes. What are radios going to look like? Because when I do FT8 over my shoulder here, I've got a 7300, Nikon 7300. It's a very nice radio. I've got some mods in it and all that kind of stuff. But when I run FT8, I don't even look at the radio. I don't even touch the radio because all that stuff's unnecessary. Because the other subtle thing about the QDX is it doesn't take any extra parts to do what it needs to do. It's all programming. It's not like in the K3 where you program the radio to do stuff in the circuitry, turn things on and off and do all that stuff. In the QDX, it is the stuff. You don't need the external, that like in the modem part of it, they turned it into an FPGA, not an FPGA, but into a software-defined radio. They bring the IF in at 12 kilohertz, and they process it, and they send it out through the USB port. That's a whole different orientation of how to build a radio. And the only really analog parts in it are the receiver front end and filters, and the four little transistors, and the PLL, and the same filters used for output. That makes it very small and very simple, and kind of answers the question. But it's not the end of the story.
But wait, there's more.
There is more. There's two more steps. One is let's see, this guy. This is micro.
I love it when Doug builds up to a story.
Micro SDX, a Chinese job, and it's the version 2 plus, V2 plus. There's a difference, even though they look the same. There's a difference. This has a speaker in it. It has batteries in it, 4 amp hours of battery. Okay, and then a speaker, kind of odd little speaker, but it's only $150, and it's 8 bands. No tuner in it, but it's got 8 bands in it on phone, CW, FM, and AM.
It's the micro SDX?
Micro SDX Plus version 2. I got mine on AliExpress for $148. You can get it off.
Is that the Asher Farhan design? There's the micro BitX, and I thought there was people that were turning that into an SDR rig by like patching out I and Q or something and feeding it into a Raspberry Pi. Is that what that is?
No, I don't think there's no.
I think Asher's...
You're right. There is an I and Q output, so yeah, you could do that.
Huh,
but
okay.
It gets away from the thing that here's the batteries and everything you need except a key and an antenna. And as soon as you start doing that other stuff, you get it fulminates. You get stuff all over the place. And if you're going to really do portable, tiny stuff, you want to have a minimum of wires. Yeah. And which brings me to number 2, and that is that on my microwave radio, I use an IF radio, usually 2-meter IF radio, because I get 10 gigahertz transverted down to 2 meters. But I have a new Kuhn DD6NT transmitter that puts out on 28 megahertz. So I can use this as my IF radio, sideband, CW, FM, whatever, for 10 gigahertz. And that makes everything smaller.
How much power does that thing put out?
5 watts. So I can turn it down and run it as a transverter output, or I can use this to go play with an antenna outside. It has an on-off switch, which most of them don't have. Okay, the last step is the craziest step. I ordered a Zingo. Well, whatever right. I say, it's not going to be how it sounds in Chinese.
Right? I thought you've been practicing your Chinese, Doug.
At least his handwriting.
I don't even. Yeah, I'm limited to handwriting. That's hard enough. And if you're going to speak it, you've got to decide which dialect of the 300 you're going to speak. Okay, so I know ni hao ma, and that's about it. Okay. Oh, and chow it's my favorite food, but I know in three. Never mind. The 6100 X6100 came out this year, I think, and they've been getting out into ham shacks, and there was supposed to be one in mine, but it got shipped out on New Year's Day, and it's still not here. And I did everything I could do to keep from cussing when I talked to UPS. I talked to the Radiodity that markets it in the States, and I said, I'm going to be on a show tonight. It's going to talk about your radio, so make me happy. And they didn't. It didn't show up. So I'm a little tweaked about that. But here's what the big thing is. It's a Linux based radio, pretty similar to the QCX radios. No tuner. It has batteries in it, 4 amp hours of batteries, and pretty much everything you need. But having a Linux computer in there with expandable memory, guys have already gotten into it to try and fix it up. Now it's got a waterfall on the front, a full pan adapter in a box about this big, and it's I think it's $600 or $650, so it's more expensive than the QCX ones and the QRP Labs. But one of the projects they're working on is to integrate some version of FT8 into the radio.
Nice.
So when you push the mode button to FT8, the screen changes to the FT8 screen, and the station starts scrolling down the screen, and it'll log the contacts. So you go from having a radio and some kind of computer to run FT8 on to one box, and it's this big. And I think that's the gold mine. The first guy that gets that going is going to change ham radio, because all of them are going to do that.
Yeah,
I come with a radio, the 705 with the built-in WSJT, and I don't know if Joe Taylor is working on it now, but it's going to take some doing, and they're probably going to pare down the programs. Instead of having 10 different modes like JT65 and all that stuff, they'll just do FT8.
You know,
And
I was thinking as you're describing that,
would make an excellent IF radio for the microwave bands.
Oh, running WSJ or FT8?
AMCW FT8 on the microwave bands with that as an IF on 28 megahertz. Now, there's one other little tiny piece of information, and I haven't tried it yet, but one of the irritating things about running microwave contests that Dennis and I do every year is that you need a liaison radio on the Cactus 450 system, and you need your IF radio on listening to the what's going on in the band. And for that reason, you have to stay close to your radio, either your regular radio, or if you've got a handy talkie, listening to Cactus in an ear. If you use a Bluetooth transmitter, like people used to plug in their TV and sit on the couch with the earbuds in, use one of those setups with your radio. You can have, I can have the Cactus in one ear, get another setup, and have the IF radio in the other ear, and be anywhere within 30 feet of the radio. And since I'm only using one earpiece of each setup, my wife can have the other ones, and she can listen to what's going on and do logging, sitting in the car drinking a soda.
Nice.
Nobody's done that yet, but I'm sure Dennis will, because Lisa's going to get the other piece of the earphone, right?
So going back to your idea about getting the application software running on the general purpose processor inside the radio, I totally agree with you. I think as soon as that becomes a thing, that everybody's going to go buy one of those things. And I think for different reasons. I think for some people, let's say, if you want to do soda or whatever, you could bag a bunch of contacts and bang them out on FT8, right? But the other thing is for emergency communications, that would be an outstanding thing to have, because you can imagine in your little, teeny weeny little case, you pop open the box, you have that little radio unit thing, a hunk of wire you can toss, in a tree, plug in the battery, and you're on the air. So if you had, let's say, FT8 for regular contacts and something like JSA call, where you get the same kind of performance, but you can actually say something like, I need more water or whatever your traffic is, that is a killer app right there. That is it almost connects back, Marcel, to our discussion earlier about bandwidth and throughput versus frequency. And so like in the array of emergency communication gadgets that you can have, that's kind of at the far extreme, which is I have maximum distance in the smallest possible package, although I can't say much, but I can certainly send a text message with that's meaningful.
Well, the Zingu also has a mini card reader for the little tiny chips, 64 gigabyte chips. It'll read, you can put that in there and that becomes an extra drive to the Linux computer that's in there. So you can write stuff in the Linux hardware that would look to the card to see the WSJT program, do all the logging, you punch it out, and or because the radio also has Wi-Fi, you can export and import stuff. Now, the guys have figured out how to make the Wi-Fi work, but it allows a portal into the radio for somebody to dink around with your radio inside. And I would personally not want to have any access to that because you could brick the radio in a really big hurry, or somebody else could. But the Bluetooth seems like a really good way to go. Especially for that practical thing of how can I listen? How can two people listen to the same things? Or how can I be aware of what's going on the radio and not have to be right in front of it? Because in emergency situations and in general contest stuff, you could go to the porta potty and be listening to your radio. And if you dropped your phone in the porta potty, you wouldn't cry.
CQ porta potty, CQ porta potty, CQ porta potty.
Well, the crazy thing too is like the price point that we're talking about is pretty reasonable. I mean, that's a amazing set of features for
micro SD is $150.
Mm-hmm.
The QDX is less than 100 put together. But the Zingu is going to be $650. But the competition is the ICOM 7500, and there's no access to the inside. Nobody's in a position where they can get into it and do anything with it. And it may not be Linux based or anything. It just happily turned out these guys found out it was a Linux machine.
Well, I would imagine, most of the radios going forward, I mean, they all the high-end radios pretty much have a built-in Linux kernel running. I mean, if you look at a Flex or a K4 or anything, I mean, all of these, just like routers and everything else, it's a little embedded Linux gadget that happens to be an appliance, so you don't really know, but it's really running an operating system inside, and why not? So, well, very cool. Doug, is that all you got on the bench right now?
No,
I'm disappointed. Oh, okay. One more.
I've been sitting playing with the QRP radios, listening to code practice, and having a good time like I used to when I was a lot younger. And it brings back some memories, and I'm having fun. And my code is still pretty good. And I've been playing, and I love playing in the lab. My spectrum analyzer makes me happy. I find little projects to do and so forth. There is 122 gigahertz. Tony KC6QHP came up with a 3D printer case for 122 gigahertz, and I came up with a Teflon lens to magnify the signal from the horn antenna, and that's caught on pretty much like wildfire. Everybody's going to make that pretty much the standard rig for 122 gigahertz. And in the contest, the last summer's contest, there were 11 logs turned in for 122 gigahertz. And there's never been, I don't think there's ever been a log turned in on the band. And it's because
awesome.
The Aussies made this radio out of a radar chip that works.
What's the max distance you've seen so far? Someone working on 122?
Well, for me, horn to horn has been about 3 miles. And if we really, and this is at sea level, and the moisture vapor losses are, if you go from sea level to 4,000 feet, the loss goes from 200 dB down to 6. So you want to go to Owens Valley if you're going to do this, but here it was 2 or 3 miles. Mike Laval, K6ML, has the world record at 134 miles with addition.
Oh, no kidding. Wow.
On 120 and on CW. So how do you generate stable CW on 122 gigahertz and then find the guy you're looking at with a like a 1.5 foot dish? Because the beam width is like 0.2 of a degree. So if you've already got a weak signal, how are you going to find where the guy is?
Yeah, that's amazing. I know that Mike did the shot from Mount Umunham to
That's the one.
Mount Vaca. Was that that one?
Yep.
Yeah, that's amazing.
Oh,
Well,
it doesn't take long talking to him to realize this is a smart cookie.
oh yeah, Mike's very sharp, to say the least, and very active in the microwave contests and stuff. Well, that's great. Thank you for sharing that. I want to take a quick break.
Can I do before we do? Can I take a follow up on the Doug thing? You have successfully spent money on this show, Doug. Because
I've gone down the rat hole, Mark.
Well, the you have spent my money. I ended up buying those the DT71s. The best price I found was on Adafruit. They are $70.
Wow.
So
do you like it? Have you used it and do you like it?
I don't know. I literally just clicked buy.
Oh. All right.
I'll let you know when it
have them
arrives
yet?
in a week.
You just did it
Always
tonight.
fun.
Okay.
Amazon same minute delivery.
Yeah, this is the challenge of this show is like we consider it a successful show if somebody buys something before the end of the night. And congratulations, you have accomplished that. I have bought the DT71 tweezers.
You will love it. Let me know by email how it is. And usually it's Vince who slits his wallet when I talk. So,
Yeah, you're right.
And I bet the best thing about that is what pushed you over the edge is the fact that it's left-handed or right-handed.
Yes.
And I'm sure there's some engineer somewhere that said, why don't we do this left-hand thing, and kind of slipped it in there.
Yeah.
We'll capture an extra 6% of the market.
That's right. Well,
it's a rabid 6%.
Yeah.
What percent of the amateur radio market is lefty? Has anyone done that research?
Oh, good question.
I don't know.
They did two things that are not ubiquitous in that kind of test equipment. They did the left and right thing. Oh, crap, I forgot the other thing. I forgot.
The right and left thing
is a big deal. Yeah. And I can't remember what the other one was.
Very
77
cool.
years old. My data stream sometimes gets interrupted.
So on that happy note of lightening Mark's wallet, we're going to take a break and we'll be right back. Which for those of you in the live stream, there is no break. We're just going to forge ahead. But
yeah, that just means one of us is going to get up and walk to the fridge.
Yeah, I was going to say, speaking of interrupting streams, I will be right back.
All right. So Dennis, how are you doing? Are you ready to do your segment?
You bet. Oh yeah,
right.
It's been great.
All right. We're gonna come in and you're gonna be the center of attention here while everybody else is adjusting their attitude.
Yeah, I'll flash that up as soon as you get going, Dennis. Once you get on, I'll step away and do what Mark is doing too.
Okay, I'm gonna.
And George can be TD while I do that.
All right, I'm gonna go ahead and bring up Dennis.
All right.
Yep, you got it.
Okay, here we go.
We're going to be at the other end of the spectrum now.
Wait,
about things.
Yep.
We're counting down.
Wait,
stand by.
Watch George's fingers.
Can't see
Watch
them.
the magic fingers. All right, Dennis. So it's your turn. So tell us what's on the workbench.
All right. Yeah, I couldn't see you, George. So, well, at the other end of the spectrum, Doug's been talking about radios getting smaller and smaller. I'm gonna share with you a radio that got bigger, and it's got a whole room all to itself. So, we're talking about using AM broadcast band transmitters on the ham bands. And this has been a project I've been working on for a number of years. I actually got this first transmitter 12 years ago and had it on the air at my old home in Fullerton. And I moved up here, took everything down, put it into storage. And I've just now, in the last year or so, been getting things back together here in the new ham shack. And I've finally got this transmitter back on the air. So it's actually in the next room through a window. And I'm sitting in the studio. This is all vintage gear. This is all the transmitter and the mixer that I'm using. And I'll switch cameras. You'll be able to see the mixer. It's too big to fit on my workbench. So that's why I'm not in my shop. It's a little too large for the workbench. But I've been doing a lot of work on this, trying to automate things. And George, you were a great inspiration for me from I think it was on QSO Today, the Ham Radio Expo. You were talking about some of the automation things. Mm-hmm. And so sitting right down here in front of me is a Stream Deck.
Oh, excellent.
And I've got the Stream Deck interfaced to let's see, I got to remember what the name of this thing is. It's a digital loggers, a web power switch. And so from that, I can turn in all the auxiliary equipment without getting up. I used to have to get up and switch a bunch of switches and turn on stuff in the racks and all that. Now I can just sit here and push a button, and you can see my graphic equalizer and compressor limiter came on. And you won't be able to see this because it's out of camera view, but if I hit that, the mixer just, you saw the light come on, the mixer just came on. I can bring on my receiver. I just turned on the R390. And the other one is the VFO for this system, which happens to be an old HP synthesized generator, and it's going to get noisy. But that synthesizer sitting up here. The only problem is the memory isn't good on this synthesizer, so I have to go in and.
What is that sound?
Oh, I know what I'm getting.
Oh, it's your receiver.
Oh, it's my receiver.
Hope that wasn't the synthesizer.
Yeah, that was weird. But I've got to go in and manually enter the parameters into the VFO so that I can use it. So this system is set up on 75 meters right now, and I won't be able to put it on the air live because we had some high winds today, and I've taken down all my antennas that were blowing around like crap. We had some high winds, so I did take stuff down today. So they're on the ground right now, unfortunately. So the other thing is that this is an old Collins 550A1, and it's a 500 watt, 250 watt. It's 250 watts on low power, 500 watts on high power. AM broadcast transmitter that's been modified to work in the ham bands. And of course, those transmitters were designed for remote control. So all of that's already built into it to be able to turn it on and turn it off remotely. So I just have to push a button and the transmitter just came on. And if I switch cameras, and I'd like to do that because you should be able to see this on the other camera, I hope. Let's see. Yeah, you can see the meter bridge.
Oh, wow, yes.
Yeah, you can see the meter bridge in the other room in there. And once this thing is warmed up, it takes a few minutes. That's part of the ongoing project is remote control. Right now, I've got the remote control working where I can turn it on and off, flip the switches and all that. What I don't have is the status coming back. So I've got the transmitter has 230 volt lights for their status indicators. And these are LED switches. So I've got to rig up a circuit for that to be able to use the switches and have them light up when I push the button. So I have to kind of look over the top of the window sill there and look at the transmitter. But I also have some other test equipment out in the room out there that you can't see. It's off camera, but there's a modulation monitor and a frequency meter that I can actually monitor my output. And I can turn that on remotely too in the other room, which is, I got you to thank for that, George. Those Stream Decks are awesome little gadgets. So,
see, Dennis, I'm basically lazy. So if I could flip a finger and not have to get up and go flip a switch, I'll do that every day of the week.
Well, when you consider the fact that my transmitter's in another room, yeah. so why not? I want it all right here. So it's all absolutely right in front of me to control everything.
So I've got some questions for you.
Yeah.
Well, first of all, I got to say that the station is incredibly beautiful array of gear. So I can see what looks like a 75A2 maybe and an HRO.
Well, there's an HRO 60 and the other is a 32V2 transmitter.
Oh.
Mm-hmm. That's some more of my AM gear. And then the stuff you saw behind me, if I switch back to the other camera that I was on originally, this is some of the ongoing projects here. If I swing the camera around, you can see there's another desk, and I'll tell you a little story about the desk too. But that's a Collins KW1 transmitter, and there's a couple of 75A2 receivers and a 32V3 transmitter back there. There's also something really cool right there. That is a Collins transmitter from the 30s. That is a 30 FX. I can't remember which one it is. It's an FXR or an FXC. I always get confused. I have to go look at the name tag on it because they're the same transmitter, except one gets a tuner in it. But that is an original 1930s Collins radio transmitter sitting there.
Wow.
And so that's That's the tall, skinny one, Dennis?
Yeah, that's that one right there in the center,
Yeah.
the rack. That's there.
Right on.
Yeah.
Yeah, so
Yeah,
for
that's
those the listeners that are just listening to this,
Yeah.
what he's showing us here is a pretty impressive studio with several full-size racks, floor to ceiling, with various pieces of test equipment and broadcast equipment, and then
Mhm.
2 benches filled with boat anchors, and just beautiful, beautiful dials and knobs and glowing tubes everywhere. So if you do get a chance to check it out on the YouTube stream, definitely do that. This is a pretty impressive setup you have, Dennis.
You can check
I
out.
will say,
Yeah, go ahead.
one of the things that makes me the happiest about this particular studio setup is that it makes me feel young. I'm pretty sure there's nothing in that room that's younger than me.
There might be. If you look up the rack, I do have some
The
modern.
Stream Deck.
There's a Perseus SDR software-defined receiver sitting right there. So
Oh,
that's
fair enough.
probably the most recent piece of gear in here. Everything else is ancient,
Yeah.
like me.
It's beautiful, though. Like you.
Thank you. I appreciate that. And this is just one room out of my ham shack. There's more rooms and more radios and more stuff that way. But yeah, go ahead.
I got to ask you about the transmitter. So did you get that transmitter, acquire it in functional condition, or did you restore it?
Yeah. Okay, there's a story behind this transmitter. This transmitter showed up on eBay 12 years ago. And I was getting interested in, I've always been interested in big radios. I've always had big stuff. I should have stuck to stamp collecting. I mean, this stuff weighs a ton. These 32V, the 32V3 over here weighs 125 pounds, and it's sitting on the desk. They are truly desk crushers. But as I've gotten older, it's a little bit more difficult for me to move this stuff around. But I decided I wanted a broadcast transmitter. One showed up on eBay back in 2010. And it had already been converted. And I can tell you this, share the story about that. This transmitter was purchased by a fellow in, I believe, North Carolina, who was vying for an auctioned off frequency in the AM broadcast band. He wanted to build an AM station. And he lost the auction. And so he had the transmitter, and it sat in a garage for a number of years. And a fellow by the name of Mike Durow, some of you may know that name, Mike Durow, KO6NM. Mike is an extremely well-known and extremely brilliant audio engineer who's worked in the broadcast and recording industry for years. And that's a piece of his equipment right there, a discriminant audio processor, a little Durow box. Mike did the restoration on it and conversion. So you have to convert it to the ham bands. Typically, these transmitters will actually operate on 75 meters. They'd like to be on 160 meters, but they'll work on 75 and even 40 meters. But the problem is an AM broadcast transmitter, you turn them on and they always transmit it. And well, that's no good for ham radio. We got to be able to turn them on and off and transmit and receive and all that. So the transmitter has to be modified to include some circuitry to do the antenna switching and of course muting a receiver. And that was one of the things that, let's see, I'm back on there. I turned the volume down. Yeah, you have to be able to mute that receiver when you transmit. And one of the other things that I have to be able to do is the VFO. Since it's transmitting on my transmit and receive frequency, I have to mute the VFO too. So I've got a relay, and that's the last piece I'm working on right now. That's the last thing that has to be completed, is that signal generator that has been modified to include a relay that when I'm receiving it terminates the output into a load so it doesn't transmit. But just the way it is right now, that is not. I don't have the circuitry hooked up to that. The VFO's been modified. I just haven't. I haven't hooked up the mute circuit to it yet. But all of that, those mods have to be made to this transmitter to. To be able to put it on the ham bands and use it as a ham radio. So that's the stuff that Mike did. Now Mike restored it for another fellow, and that was Ed, K6EGS. He originally got the transmitter from North Carolina. Mike did the restoration, and it is beautiful. It actually looks better than a new Collins, one of the Collins transmitters, because the paint job on it, they did it in an appliance refinishing shop. So it's gloss, beautiful gloss finish on it. and the thing just sparkles, and it's all the Collins gray, and it's quite beautiful. And when it's all lit up like that, it's pretty impressive.
So
that's
when the transmitter is used in broadcast service, obviously it's parked on one frequency.
Right.
What do they use as the frequency controlling element in those transmitters?
This transmitter used a crystal oscillator. It's just a crystal. And so actually, if you know a little bit about the history of AM broadcast and the old Conelrad system, transmitters were designed to operate, they had to be able to switch to two different frequencies. So if there was an emergency, the broadcast station would have to switch over to that emergency broadcast frequency, which was a fixed frequency also. And so these transmitters are set up with dual crystals with a little switch to switch between them, and a little crystal oscillator in there. And that has that. Although I'm not using a crystal oscillator, we're just running the VFO output right into that stage, using it as a buffer before the driver of the transmitter. So the transmitter is all vacuum tubes. It's running it's right now running 4-400s. There were 5 of these transmitters in this series. The low power one was a 300J, and that was a 250 watt transmitter. this one is 550 watts. There was a 1 kilowatt version, which is the 20V series. So there's a 20V1, 20V2, and then a 20V3, which is more modern. And then there were 2 high power stations. There was a 21E, which was 5 kilowatts, and a 21M, which was 10 kilowatts. This radio here, this transmitter, the 550, is the driver for the 5E. So that it's all part of that same product line.
I was actually going to ask you how much power these things are capable of putting out.
This one right here is capable of putting out, well, at 500 watts, it on peaks, it would be putting out 2,000 watts. So obviously I can't run it legally like that. So we run it at low power, 275 watts. And a 100% modulated carrier on AM, your peak power is 4 times the carrier power. So 275 watts is the legal limit, which would be 4 times would be 1,500 peak power. So running 250 watts on here, actually running between 250 and 275. So it's right at the legal limit, which is perfect. So one of the big ones,
that's a little below legal limit.
Well,
275 would be 1,100.
Yeah, that's 1,100. That's right. Yeah. So it should be 375, but this will only run 275. So that's what I'm stuck with. Okay. 375 would be legal limit on AM. And of course, I have equipment that'll do that, but this not a beauty like this. Yeah. Some of my modern gear. I've still got 2 more transmitters in there that are waiting to be restored, actually converted. One's in the process of being restored, and it has to be converted over. The other one just needs to be converted over. One of them is another wonderful boat anchor, and that's a Western Electric 451A1 that was built sometime in the mid-30s. It was the last AM broadcast transmitter that Western Electric built. That series, and there's probably maybe a half a dozen of those things in existence, and it's quite a beautiful transmitter. It's very Art Deco, big glass front with etching Western Electric etched on the front. That's a pretty transmitter. And the other one is another Collins, and it's an 820D2, which is a more recent, still old but more recent product. That's another AM broadcast transmitter that has not been converted yet. So I'm going to be doing all the conversion work on that one. So that's going to be fun.
So for those transmitters, do they just need like some cleanup and polishing, or do they need some fundamental rework and replacement of components?
It depends. If you get one out of service, it's been used, it's been on the air. Typically, these things are used for low power AM stations and as backup transmitters at AM stations. And a lot of times when the station upgrades their equipment, they get rid of these things, and they end up in a landfill. So one of the cool things is we save these things from the landfill. We put them back on the air. And if they're out of service, chances are good it's in operating condition. If it's been sitting around for a few decades, it might need some work on it. The 820D2 is going to take some work because somebody did some work on it at some time. I don't know if they were starting to do conversion on it, or I think they were switching to a different tube. So there's a lot of wiring that's been disconnected in it. So I've got to go through and get all that figured out. Thankfully, I've got all the manuals too. That's another important thing. having manuals for all this stuff is one thing that you really have to have your hands on. And so I've got a manual for the broadcast, for the transmitter. There's the transmitter manual right there, and that's an original manual. It's not a reprint, which is kind of nice. But I stuck it in a 3-ring binder so I don't destroy it. And I've got the original manual for the mixer, the broadcast console. So,
so is the mixer Collins also, or what is the?
Yes, this is Collins.
I know they made mixers.
Oh yeah, Collins did quite a bit of broadcast equipment way back, early days. They were building mixers, and I actually have several Collins mixers. Go off camera for a second.
So there's a question, Dennis.
Yeah.
What's the power required to run it?
Okay, this transmitter uses 220 single phase. 220 single phase, and I'm feeding it on a 50 amp. We've got a 50 amp circuit going into that room, and I think it's either on a 20. I think it's on a 20 amp breaker. So that give you an idea of what.
I also have a Collins mixer. I have a 212 mixer. It's a solid state mixer.
You got the little solid state one. I used to have one of those.
Yeah,
and I replaced it with this one.
Oh, Dennis, I had one of those and I sold it to a kid.
Oh,
I don't know why. They're beautiful.
Yeah, this is a beautiful little, and this thing is absolutely pristine. I mean, if you could see it in person,
tell our listeners. Yeah, describe it.
This is a what they refer to as a remote mixer. So if somebody was doing something on location from a radio station, this would be what they'd be using on location. And it's 4-channel. It's got 4 inputs. It's got line outs. It's got monitor outputs, and it's a 212Z1, 212Z1, 212Z1 remote amplifier. And this was my first. Actually, it was my second mixer for doing AM. The first one was one like Doug was talking about. I had one of those, which was the little solid state mixer, and I can't remember. Doug, do you recall the model number of that? It's another 212 something or other.
It's a 212.
I just can't remember.
J-1.
That's it, 212J1. Yeah, so I had one of those and got rid of it. I replaced it with this monster, the 212B2, which is this guy sitting here on my desk. But I also had this little guy too, which is this one's fun. And it's all transistorized.
Dennis, Dennis, that was going to be my question. That portable mixer, so it's vacuum tube or it's transistor. Tell us how much it weighs. What kind of power does it take? You say the word portable, but to a kid like me, I only think of transistors.
Okay, fair enough. This is transistorized germanium transistors. Okay, so It's old. It is germanium. It has internal batteries, so it is portable, but it also runs on 110 volts. So the thing probably weighs maybe about 10 pounds, 12 pounds, something like that. It's not exactly super lightweight.
Well, it's not exactly a tank either, though. So that's
true.
Not
like this. Yeah. This thing weighs. This mixer really weighs in. I mean, this has a massive cast case that everything sits into, and the whole thing. This thing is a work of art. I mean, the way this thing opens up to work on it. Part of what
Z1 is what you use when you take your Collins out for POTA work.
There you go.
POTA and soda work. Yeah.
Soda. I'm gonna take that. Take my Collins rig out for a soda.
To the top of
that's the mixer for it.
One of the gobsmacking things about that mixer that you're sitting in front of is that if you open the lid and look in, it's terrorizing because it must have 200 connections to it. You can connect that mixer to everything in the studio and the station and run everything from it, but you have to do that. You have to have wiring harnesses and crud that goes in there, and then know what terminal is what terminal, and that's pretty daunting.
Yeah, it feels like an opportunity for a good labeling making machine. Go ahead, Dennis.
And the other, and it is. And the other thing that's really important is documenting. And I wanted to share that. That's one of the most important tools on my workbench is a journal. Everything I work on, I log in my journal and keep notes on what I've done. And so years from now, I can go to my journals and I can say, oh, well, how did I fix that before? there it is. It's all in there. So I've got notes in here on the 550 on getting it back on the air and getting it up and running. There's notes in here on the mixer here. But the other thing, I've totally documented how I've wired this thing up. So I've got a notebook that has all my wiring diagrams, and because there's multiple patch panels, you see patch panels behind me. There's a terminal board that everything goes to in back of the rack. And as Doug was talking about, yeah, there's the wiring harness. So that's got to that goes out to a panel at the back of the rack. Then it comes up to this patch bay and then goes all to the equipment in the rack. So
that appeared to be like about 100 points of connection in that wiring harness.
I can't remember. It's not
terminal
quite,
strip.
It's not quite that many. I think it's probably about 50 in there. And of course, it's all balanced. All the audio lines are all 600 ohm balanced, and
right.
Of course, and you got microphone inputs. You've got since this is a broadcast mixer, it's got things like what it calls
Q channel.
Well, TT1 and TT2, transcription turntable number 1 and transcription turntable number 2. But it also has four microphone inputs, one of which is the control room. It's the talkback mic, which would be in the control room, and that's the one I'm using right now. And you can hear I don't know if you can hear the relay clicking back there.
Oh yeah, we sure can.
So,
in my stint in Saginaw at WSAM, it was an old station, so we had mixers like that.
Yeah.
And tube transmitters, an FM and an AM transmitter, and a standby transmitter. And the show was on Sunday evening, and when the station went off the air, the engineer and I would play as long as we wanted to. Okay, if you haven't done so, please tell us about your interesting microphone.
Oh, I haven't. Yeah, I can talk about that. So this is if you know anything about broadcast RCA ribbon microphones. This is the poor man's RCA ribbon microphone. This is a 77 Junior ribbon mic, and it's really a lovely microphone. It sounds fantastic, as most ribbon microphones would. But the old RCAs, I mean, these are old broadcast recording mics. Things like I said 77. It's a 74 Junior. Sorry, 74 Junior. 77 DX, which is what I would really love to have. That's the one that looks like a big Tylenol you see all the time in the old studios. Those things go for a ridiculous fortune, thousands and thousands of dollars. This one was quite economical, but it is historical. It's in keeping with the rest of the station, historically accurate. An RCA ribbon microphone. So yeah, 74 Junior is the microphone.
So Dennis, when you're on the air, if you're on like the Collins 75 meter AM net, which there must be one, right?
There actually, there's what we call the first Wednesday, but we actually don't get it out here on the West Coast, unfortunately. But we do have some West Coast nets, yes.
So when you're on the air in 75 AM mode, what of the gear you're talking about is that the station? Is it the R390 and that Collins transmitter and this ribbon microphone and that console?
Yeah. This is one of my operating positions here, where I've got the 550, the Collins transmitter, the mixer, my audio chain, and the R390A receiver, and listening on 3870 kilohertz, which is the AM calling frequency, but that's where we hold our net here on the West Coast. It's the AMI West Coast net and AM International. And the AM window on 75 meters starts at 3870 and goes up to 3890. So we do have some other nets that run on there. The Collins Collectors Association has what we call the first Wednesday Collins net on AM, and it's on 3885. But I have a hard time with that on the West Coast because we don't have many stations that participate with that out here on the West Coast, unfortunately. So
Dennis,
what kind of bandwidth do you transmit?
Say again?
What kind of bandwidth do you transmit?
6 kilohertz. We try to keep it within 6 kilohertz. So that's, it's typically that's what you run on AM. AM is always going to be wider than a sideband signal.
And that, to be clear, that's 3 on either side of the carrier?
3 on either side of the carrier, right?
Okay.
So you're basically just voice range, vocal range.
Double sideband, basically. Yeah.
Double sideband with a carrier. Yeah, that's
Yeah,
it.
yeah.
So as you know, I mean, AM is, sideband is so much more efficient because you don't have the carrier. All the power is going into the one sideband. In the case of all the power here, it's going into 2 sidebands in a carrier, so it gets distributed out. So we don't have the talk power that sideband has.
Well, but one of the things that's attractive about the AM is you get an R390 with an 8 or 16 kC filter for receive, which is the other half of the equation, and then a 6 kC or better wide transmitting signal. That is mighty, and a nice microphone is mighty nice to hear.
It sounds wonderful. And that's one of the neat things about AM, I think, is that it's a different crowd. There's no, and I mentioned this elsewhere, that the typical QSO on AM, there's no, great signal, 5.9, thanks for the contact, see you later. None of that on AM. It's, we have push to talk, but you key the transmitter and you talk for 10 minutes. So
Dennis,
it's nice.
I had a few questions just about your setup. For those of us not familiar with the kind of setup you're in one room right now, which has a microphone and some mixers, but then you also have a glass window that's going to another room. And from my limited experience, I'm used to seeing like recording studios where you'd have the artist in that room and you'd be in the mixer. Could you maybe describe the setup that you're in and like what's in each of those rooms and how's that set up?
So we have when this building is completed, it's only halfway finished right now. I have 4 rooms in this part that's completed. So there's what I call the transmitter gallery, which is where the 3 transmitters are located, and that was a special built room. These things are not lightweight. Doug's talking about little tiny radios. I'm talking about a radio that weighs 1,000 pounds, half a ton, and I've got 3 of them sitting in there. So they're in a separate room. We built a special room with reinforced floor. It's got a plywood floor that's 1.5 inches thick to support it on some gigantic timbers. And so that room isn't going anywhere. When we had our earthquakes out here in 2019, the room was finished. The transmitters weren't up and running. The room was up. The transmitters were in there, but they were just sitting in there, and they moved across the floor, which that's pretty crazy. They ended up on the other side of the room because they are on wheels anyway.
And they're in that room primarily because of noise and fan noise?
Noise and heat. So it's in its own room. It's got its own air conditioning system or heating system, depending on, wintertime, I don't need the heat in there, but the transmitter does a good job of keeping the room hot. But primarily to isolate the noise. And then the studio, what I call this is Studio A, which is where the receivers and some of my other gear behind me over here is located. This stuff isn't quite so noisy. The noisiest thing in here is this silly generator. And I will share with you that this is going to go away. This is temporary. I have another project, which is actually on the workbench, which is a Technical Material Corporation master variable frequency oscillator. And that I recently picked up, and that's going to become the VFO for my AM station here, which is more in keeping with the nature
brand. Yeah.
It's vintage. The other thing that's going to change out is these are modern. The compressor limiter and the equalizer are DBX products, so those are modern equipment. Those are going to get changed out to some other gear. I've got some old CBS Labs Volumax and Automax compressors that are going to go up there, and I've got to find myself a vintage equalizer. So that'll be on my agenda.
Well, what's going to happen to the Duro processor there?
Well, that'll stay. That's back from the '60s, so that's vintage enough for me. That's been around long.
I thought it was going to go to K6JEY there for a minute.
Oh no.
It's older than me, so it can stay in the shack.
Yes.
Okay.
When you don't need that DBX anymore, I realize it's only 1980 vintage, but I could probably make room for it here.
Young.
The DBX is actually recent. I just picked that up a few years ago. It's a 160A, which I think is still a current product from DBX.
So, Dennis, we had a question. Is your receiver an R390 or a 390A?
It's actually, this is a great question. It's neither. It's actually an R1247 GRC 129, which was produced by a company called Manson Labs. Now, what this is an R390A. It began its life as an R390A, and it was modified to use an external frequency synthesizer from the original, external. The synthesizer's as big as the radio. But this radio, it'll work fine without the synthesizer. It's designed so that if you don't have the synthesizer, it still works as just a regular old R390A, and that's what it is.
Do you know why they would have an external synthesizer?
It was for some special application I've
Maybe
heard
a frequency hopping kind of thing, or
I'm not
why
really
would they
sure.
want that?
It could have been. I've heard stories that it was like done for NASA for some special program that they were doing. There's so much lore, R390 and R390A lore out there. This one is quite spectacular. Another spectacular radio. This radio has not been restored, and it's absolutely looks like it just came out of the crate. It's pristine, absolutely pristine, and it's just a to find something. I mean, that thing's nearly as old as I am. I wish I looked that good,
Well, the R3, for people who've never seen it, the R390 is if you ever see like a picture of a battleship and there's a rack mount HF receiver, that's an R390. It looks like it could withstand a direct hit with a pretty significant shell.
But Dennis, turn the main tuning knob so we can hear it.
I have to unlock it.
Okay.
I don't know if you can hear it or not.
It's a beautiful sound.
That's the Veeder root counter dial. It's a mechanical counter dial on there.
You let the hamsters out again?
Yeah.
The amazing thing about that is when you open it up and take a look inside, the first 2 inches behind the front panel is like a clockwork, a bunch of gears, and it's mechanically beautiful. I mean, it's unbelievably complicated.
It's unbelievably complex. And what it is, I saw Rory's comment there about no Optimod. No, Rory, I don't have an Optimod. I'm sorry. I do have some other stuff, though, that's not in here. Yeah, it looks like it would take a bullet or 3. Yeah, they're pretty indestructible.
How did you find that one?
It found me, actually. A mutual friend of Doug's and mine and my wife, Lisa, offered it up to me a little while back, and he had acquired 4 of them, and he said he kept the best one out of the bunch for me. And
it fell out of the sky and landed in your front yard.
I'm sorry?
It fell out of the sky and landed in your front yard.
Sort of, yeah. And Doug, I don't know if you know who I'm talking about. I'm talking about Wayne.
Oh, yeah.
Yeah, our dear friend L6IRD, who just turned 90 before Christmas.
The grand old man of Collins stuff. Yeah,
he's quite a man, quite a guy. Both he and his wife, they're incredible people. But Wayne is always looking out for stuff for me, and so he set me up with this receiver. I've got this is one of 5 that I own, but this is by far the only one that's going to end up here because it's so perfect. I've got another one that was restored some years ago by Chuck Ripple. And that's a beautiful radio too, but it is a restoration, and the others are awaiting restoration, so they need work on them. Now, the interesting thing is, you mentioned R390. There's two different things there. The R390 was the first one, and it was originally designed in 1952 with their first contract, Collins Radio, and it was an extremely expensive radio because it had lots of custom-made aluminum castings and all kinds of crazy stuff in it. So the government came along and said, we want to do a cost reduction version. And that's where the A came from. And so it was reduced cost, and they put it out to multiple contractors to bid. This is really Korean War vintage gear. You think about it, Vietnam. These were used extensively in Vietnam. Something like in the order of over 50,000 of these things were manufactured, the A models. And I have one R390 that was made by Collins. They're the only ones that manufactured the 390. The 390A was made by all kinds of contractors. The nice ones, Motorola probably made more than anybody. Electronic Assistance Corporation, which was a government-sponsored entity that was partnered with Hammarlund, right? They made them. And who is the... I can never remember. It's a cosmetics manufacturer. Actually succeeded in bidding on these things during that era, during the Vietnam era, and manufacturers. I always want to say it's Max Factor, but it's not Max Factor. It's it's kind of funny, but I can't think of who it is right now. Yeah, like Doug,
That's wild. Yeah. So now the other 4 that you have that need restoration, are they requiring mechanical restoration as well as electronic, do you think, or what state are they in?
Yeah. The typical thing you're going to do to these things, one of the problems with them, a very well-known problem, you know about this with your 75A4, because you replaced all the Black Beauties.
Mm-hmm.
Right? Well, these things were loaded with them too, and the serious problem with the Black Beauties was with the bandwidth. Your selector. You've got 4 very precision mechanical filters, Collins mechanical filters, and there's a coupling cap that happens to be one of those Black Beauties. And if that Black Beauty starts leaking, it starts dumping a little bit of too much current through that filter, and it'll burn the thing up. And so somebody turns the radio on, and they're not hearing anything. So I think, oh, well, maybe the filter's bad, so I'm going to switch to another position. Well, the same capacitor, you go through all 4 of them. You destroyed all 4 filters at one swoop like that. So that's one of the things you have to go through. This particular radio had already, I think when Manson did the conversions on these, they ripped all the Black Beauties out because it's got a bunch of Mylar caps in there. They're modern components. But some of the other ones, and of course when Chuck Ripple did my other one, when I got the other R398 from him, that has been restored with replacing all the Black Beauties. But the other ones are all original, so they have to go. So that'll be a challenge. Now, one of the things is they're modular, which is kind of neat. You just take some screws out and a whole sub chassis pulls out. Here's the IF chassis, and it's got the 4 filters and all that on that little chassis. I think 1 screw and a couple of set screws will take it out. So it's pretty easy to take apart. But
I would think doing the mechanical part would be a challenge too. You'd probably have to disassemble a lot of the gearworks.
You really want to avoid doing that. And a lot of guys get messed up when they're restoring these things, that they get the gears out of sync. There's actually the R390 has something they call the green gear. And you got to have the green gear, because what you do is you install the green gear, and it's a lock. It locks the gear train before you take it apart. Mm. And so that little green gear is screwed to the back of the front panel, and you take that off and put it where it's supposed to be, and now you can disassemble the radio and not mess it up.
Did you say green beer or green gear?
Gear, like, tooth gear.
Oh, okay. I got really excited for a second. It was the same way when Marcel asked me what percentage of IPA was on my shelf, and I was pretty sure he was talking about India Pale Ale, but he meant something totally different. I'll never
99% all the way.
I like that. Yeah. Indian Pale Ale, yes. I've retrained these. What the gear train is for? I wanted to explain that a little bit because George, you brought that up. This radio is marvelous in terms of its selectivity and sensitivity, and it's because it has things like a tuned IF strip. So as you tune the radio, as you tune the kilocycle dial, it's actually tuning the IF and shifting the IF frequency at the same time. So you're shifting all these tuned circuits. There's all these racks that the gears move up and down with a bunch of cams, little cams inside there that all move. These racks move up and down, and I think there's like 6 of them across the top of the radio, and they all move tuning slugs that go down into the tuning coils that are in the IF and the RF stages and all that. And so all these things are all moving all the time when you turn these knobs. So it's a pretty.
Let me throw in about the modifications. I've had 2 of the R390As, including one of yours, your old favorite, and the kinds of problems I ran into were really very simple, because the ascending and descending racks took a minor amount of tweaking to get them so they tracked properly, because it wasn't the kind of radio where if you adjusted something, the whole thing fell apart. Because like a Hammerland radio or Hallicrafter's radio, you start aligning things and you find out lots of things are wrong. The mechanical gearing stuff, I didn't see any problem with those. They just would get a little worn, and it would make more noise. But when they're good, they're not silent, but they're very quiet. There weren't a lot of typical parts that blew out them, and except the black beauties and that one for the condenser. And as far as wear and tear electrically, the tubes were good. I haven't run into very many tubes or anything that were bad. So they're actually, in an odd way, easy to work on because they're so high quality, even though they're probably the most complicated vacuum tube radio made, except for the National FRR or whatever that.
Yeah. That's definitely the most complicated HF radio ever made.
I would rather slit my wrists than work on one of those.
You know what I find really fascinating about looking at some of these older radios where there's a big mechanical design component to it.
Yes.
Today, when we think about building a modern radio, we're going to build an SDR with a big FPGA in it, and there's a bunch of DSP, algorithms, and so people look at that like, oh, that's black magic. How could that's so complicated? People who are really good at that, you look at this mechanical thing and you think, oh my God, how did these people ever figure out how to make all this essentially mechanical computing machinery?
It really
do
is.
What it does.
It's like an analog computer, a mechanical analog computer. That's exactly what it's like.
And that is not easy. I mean, that is the art to do that.
And
let me break in for a second. I'm going to go in the garage and get an FPGA board that I got from the Karma array at Owens Valley Radio Observatory. It's a 4 gigahertz wide SDR, and it'll be interesting because it's got 4. Well, I'll show you. The FPGA are 15 grand a piece. I'll go get the board.
I've got one of those.
That's make sure you don't shuffle your feet across the carpet while you're getting it.
Yeah, exactly. Yeah, the Karma array is their millimeter wave radio telescope that was up near the bristlecone pine forest. That's now been decommissioned, unfortunately.
Well, you have sent me down the rabbit hole of not buying, because I don't have that much spare money, but researching ribbon microphones.
Oh, yeah. There's some. I've got several ribbon microphones. I've got a Shure ribbon microphone that's actually that was my first ribbon mic that I used on AM, and it's a pretty nice mic, and it was pretty inexpensive.
So for those of us who don't know I've heard of it, but Dennis, could you describe the mechanics of what a ribbon mic is?
It's a piece of aluminum foil that's very, very delicate, stretched and that's the diaphragm, essentially. That's the ribbon. And it's either capacitively or inductively coupled to create the signal out of the microphone. So that's how these things. So they're extremely delicate. They can't withstand much in the way of shock. They need to be very carefully shock mounted.
So what you're saying is they're like really ginormous electret condensers.
Exactly. Let's see. The electret mic is kind of an offshoot of the ribbon mic was first. Then we talk about these things as being condenser mics. The condenser mic has to have a preamplifier. Typically, they're built into the microphone.
Sure.
Those condenser mics, but it's the same idea. And the electret came out of that as a kind of a solid state version of the old condenser microphones.
So the ribbons are a capacitive diaphragm?
Nope.
Because they're inductive, Doug. It's inductive, isn't it?
Yeah. There's a magnet, a U-shaped magnet with a ribbon in the middle with a connection on one end and the other, and it wiggles in front of the magnet, which which induces a current. It's very, very low impedance, and that's the bad thing. The good thing is it's very sensitive and very flat.
Very flat.
You get too close to it, you can blow the ribbon out. I mean, literally blow the ribbon out.
Yeah.
So typically, there's a great podcast episode from 20,000 Hertz that talks about the SM7, which is a dynamic mic, but goes into a lot of the details of that construction and the history and all that. That's absolutely fascinating. So if you want to deep dive there, we'll drop that in the show notes too.
Nice. Typically, you do things like putting a windscreen in front of it to keep you from blasting the thing, so you don't get the pops on it from your voice. But this one, it's actually a very sensitive microphone, and you can walk around in the room and it'll still pick me up quite well, which is pretty remarkable.
I found the board.
All right, let's see it.
The SDR board from the Karma array. It was surplused out to me, and this is the backside, and you can see all the little pins for the ICs, and this is the front side, and they are just a second. Altera Stratix. Yeah.
Yep.
very underneath the aluminum frame here is 3 more of these Altera chips. The RF comes in here at, I think, 4 gigahertz. It goes to a very small chip that is the D to A converter, and you can see the 2 channels over here, and then it goes into the ICs. But they had 4 of these. I'm not sure the whole thing, but one guy, a New Zealander, who was one of their PhD guys, designed this thing out of his head, the entire Karma array, and it was a millimeter wave radio telescope.
Long baseline interferometer. Yeah.
Yeah, and one of the things we used to like to do, Dennis and I used to like to do, is go up on the mountain and watch them, because all the dishes, 9 dishes or so.
Oh gosh, there's a bunch of them.
And they were like 30-foot, 200 gigahertz antennas, so their surface accuracy was almost optical. But they would do an alignment by all pointing at the same pulsar and averaging the readings, so they'd hit. They would put a line, literally push a button, and all the antennas outside would go zzz, and get to the star and align to it, and that would give them the time in picoseconds for the radio to travel from the one dish to the receiver and the other, and compensate for it to get them all lined up. And it was a tremendous. I mean, we got a chance to look at it really closely. A tremendous antenna setup for a 280 gigahertz millimeter wave array, and this must have been almost 1990s design. You think, Dennis?
Yeah, well, let's see, probably not that long ago. I've actually got one of those another version of that board as well. See, I've got the digitizer and what's the other?
Hold up the backplane connectors on that real quick.
Okay.
No, the backplane connector. The connector's on the edge of the back edge of the board.
Yeah, it's
nope,
Station
back edge.
controller vibes.
Other side. There you go.
Okay, let me see the whole batch of them.
That looks like the world's biggest ICOM power accessory connector.
Nope.
So, ladies and gentlemen, it's a row of pins, 5 pins tall.
Yeah.
I don't know, 75 pins wide
like
over
a-
6 connectors.
That's a
Crazy
64-bit compact PCI bus, so that had to have at least been the early 2000s. I was working.
That's like a VMI. It's almost like a VME bus, is what it looks like to me.
It's
I'm not
compact
sure.
PCI.
That's not compact PCI. I don't think so.
I was working on computers with that same backplane in 2002 and 2003.
With
That was
that,
about right for when the array was put into service. Yeah. I can read the back of one of the chips and tell you what the date is.
Whatever it is, it's crazy big with all
Lots,
kinds of
all the pins.
yeah.
All the pins.
So this was doing a big parallel signal processing task of some sort, right? What was it trying to figure out?
Gosh. Okay. So the way the receiver worked is there was a horn antenna that accepted the RF from the 30-foot dish, and it would go into a preamplifier, and it had a single-digit readout on it, and it was because that was the temperature in Kelvin, 4 degrees. Okay.
You only needed 1 digit.
Yeah, and then it would go down through a waveguide to not yet to a doer. They went to the mixer, and the mixer had the RF come in this way. It had a piece of mylar like this, and then a piece of absorber on this side. So the RF signal would go down through the mylar, make a left turn, go all the way through. They would feed the oscillator in from the side, and 10% of the oscillator signal would be reflected by the mylar, and the rest of it would join the signal. The signal lost 10%, but the rest of it would go through. It was literally a piece of mylar that acted as a millimeter wave mixer.
Like an optical.
It's quasi-optical mixer, yeah. And then it would go through a window, a lossless window, into a doer where it was kept at 4 degrees Kelvin, along with the preamp. They had a transistorized preamp, I think. It went into the doer, and it was kept at 4 because there was a diode in there that was the receiver. And because it was a superconducting diode, it was 90% efficient, and the noise figure was almost 0.
Yeah.
And then that sent out the IF at 20 gigahertz and came to 4 of these boards. It was divided out and went to 4 of these boards where it was processed.
And what were they trying to
Radio astronomy. They were looking at 280 gigahertz. There are some chemicals in the cosmos that emit a photon at that frequency. So if you're looking at a nebulosity, for instance, you not only see oxygen products, but you see other things because stuff's all over the place, and you get a better picture of what the nebulosity looks like and what it's made out of, and how you can interpolate lots of facts by doing that. So the radio astronomy takes something at orange or blue that occurs in space, but the farther you go away, the more Doppler shift attacks it, and the frequency goes down. And by 280 gigahertz, you're seeing stuff quite a ways away. But they've got an all-sky camera that Dennis and I worked on, a telescope, and it's at 40 to 100 megahertz, because some of that stuff is so strongly redshifted, it shows up at 40 megahertz. Am I right, Dennis?
Yep. Well, there's a little. So what? This is actually what's called an interferometer. Is what Doug is describing. Each antenna has its own receiver, and what you do is, and he mentioned the thing about the time delay between antennas. You know, if two antennas are pointed in the same direction, there's a time delay that the signal takes to get between them. So you have to compensate for that time delay. In the old days, it was done with a phase shifter. Then they got smart and used a length of coax that you for your signal path, and so you'd switch in different lengths of coax to change the phase delay between the antennas. Then they went to fiber optics. So they used fiber optic relays, if you can imagine a fiber optic relay, switching these little chunks of fiber optic cable to change the length of the phase delay line between the antennas. And ultimately, this radio telescope, it's all done in software, which to me is just brilliant. You put the antenna wherever you want it, and the software takes care of all the phase delays. Like Doug was talking about synchronizing the antennas on a pulsar. But what they're doing, it's a software-defined radio. But what they're doing is they're doing a fast Fourier transform on the output of those receivers to be able to create ultimately an image from these multiple antennas. And the thing that's interesting to me that has always bugged me about it, those A to D converters are 2-bit. There's only 2 bits. So there's only 4 values out of each A to D converter.
Are they that's the 2 bits for each bin in the FFT?
Yeah, you've got just, you're sampling at gigahertz, which is, it's just huge, super high frequency.
I went in the lab one day, and they showed me their usual A to D converter that was good to, I don't know what, 4 gigahertz, because they had to sample it. They had to do the IF at 4 gigahertz. And then they said, but we got a new chip. It was, let me get this right, this big. It was a 20 gigahertz A to D converter. And I think it might have still been 2 or 4 bits. But the thing would swallow 20 gigahertz at a time.
Yeah, I love the contrast of how we started with Dennis's full 2 rooms worth of equipment and massive racks, and then the card that Doug showed with this, what it was, a 4 gigahertz wide SDR on it, was literally like the size of a small paperback book, right? Pretty thin.
And that's old-fashioned. That's ancient history.
And that's old technology, right? But that's amazing. I mean, sure, all the dewars and all the liquid nitrogen to keep everything cold, I'm sure was or liquid helium, whatever you need at that point.
Yeah,
right? So, pretty wild.
Outdated about 5 years ago, because there was another array set up for millimeter waves in Chile. Chile, I think.
Yes.
So.
Yes.
And it was declared surplus. They had to not only take all the gear apart, but they had to return the property to primeval conditions because it was in a state park or national park.
Yeah, BLM, it's BLM land, so they had to turn it back to what.
So they saved a lot of the equipment, but a lot of it got surplused out, and they just disbanded it because this other one was so much better. Nobody needed it anymore.
Well, it's better because the reason that Sarah Tololo is the one you're talking about, Doug. They got the grant. See, the observatories compete for grant money from things like the National Science Foundation, right? And the Sarah Tololo Observatory down in the Andes is at such a high elevation. They're above most of the Earth's atmosphere that absorbs infrared and some of these millimeter waves. So they're also in the southern hemisphere. So to have such an advanced instrument in the southern hemisphere was something very new that we've never had before. So that's why they got the money. And it actually cost it actually cost more to shut down Karma than I think it would have cost to run it for a couple more years. But that's the way the budgeting works. So the Sarah Tololo got the money, and Karma went away. They had to, like Doug said, they had to dismantle. I had the dubious honor, and I do say dubious, that I was with Mark up at the observatory the day that the Karma array was shut down. And I went up to the array was up in the mountains up there. They're down in Owens Valley, but the array is up in the White Mountains up near Bristlecone Pine. He and I drove up there, and I actually helped him power everything down, which was kind of bittersweet because we got to see it being built down at the observatory in Owens Valley, and then I got to go up and shut it down, which was sad.
Let's. You want to tell them about our fix-it trip up there, or can we tell them about it?
Well, yeah, it's a pretty basic issue. So they have this interferometer, which is what I was describing before. You're doing all these fast Fourier transforms to create an image, a sky image. These are all HF and low VHF receivers, and they were getting all kinds of interference. And looking at the way these things were constructed, they have
280 dipoles spread over 10 acres.
But regardless, each one each of those antennas has a preamp. Each antenna has a receiver, and they're all tied together to the processor, this digital signal processor, with Ethernet cables. And it's just you open the back of the rack, and there's just these hundreds and hundreds of Ethernet cables in a big bundle. And so Doug brought along some RF sniffing gear. And so we're sniffing around in there. And what I was noticing, there was a lot of common mode noise on the cables. And I was kind of making a conjecture that they've got lots and lots of ground loops with all these cables and shields running around and all of this. And so I had suggested that they tried putting a ferrite on the cables to see if that would suppress the common mode noise that they were getting. And so we sent him off to a friend of ours who you guys may know, Palomar Engineers. We happen to know Bob very well. I know Bob very well. I think Doug knows Bob, AK6R. He does a lot of antenna and balance and stuff like that, but he also makes noise suppressors. So we sent him off to, we sent Mark off to Palomar, and they ordered some, and it fixed their problem. So it's like
one of their problems.
One of their problems. They still get a lot of QRM. From
when I went up there, I said there's either an elephant or it's going to be complicated. We'll go up there and we'll say, "Oh, why are you guys doing that?" and fix it within 5 minutes, or else we'll spend hours trying to work on it. And the receiver was in a storage container about 20 feet long, or was it a bigger one?
20-foot container, and it's 2 racks of equipment
with a Volkswagen-sized air conditioner on the top, and
Hurricane.
Through it to cool it, and these 280 antennas coming through the firewall into the radio. Okay, so Dennis and Mark are in there working on the ground loops, and I'm standing there outside because there's not enough room for 3 of us in the place. I'm looking out over at the 10 acres of the dipole arrays. They're 4 dipoles at 90 degrees, and there's 280 of them in this 10 acres. And it dawns on me what the elephant problem was. Where they originally got the array was in Socorro, New Mexico, and they just imported it and planted it in this very flat, isolated part of land on the observatory. But they had a good rain that year, and the vegetation was growing up over the edges of the antenna. And I brought the scientist out, and I said, "You've got to cut the grass, Mark. You've got to get rid of that vegetation because it's just like having somebody grab the edge of your antenna. It's dead."
Yeah. Get some goats.
And so I said, get some of your high school students and some lawnmowers and mow the thing one weekend and buy them some beer or something.
Just get some goats and turn them loose.
The lawnmowers will make too much noise. I said, then get a goat herd from Bishop and have him bring down his herd of goats, and they'll eat the vegetation. And he looked at me like I was nuts and insulted him. And I said, but it's free. All you got to do is have a couple of things of water out for the goats, and the guy will happily do it. And he said, that's crazy. Nobody does that. Well, the next time we went up there, that's exactly what they did. And they've kept the vegetation trimmed down ever since.
Yeah,
and he said it saved It saved 2 PhD dissertations. Our work there. So here's a couple of guys. We're a couple of radio hams, and Dennis has got an engineering degree. I have a degree in philosophy and theology, and we went up there and solved their problem because we knew more about VHF noise than they did.
Well, that's because hams walk around with a pocket full of toroids. That's the difference.
Yeah.
And ghosts.
And you are happy to see them.
Yeah,
Exactly.
That's
Oh, man.
That's our story. Dennis and I, we've got a lot of adventures, but that's one we can tell.
Yeah. That's one you could talk about in public. All right, we're going to take a quick break. We're going to come right back and wrap up with the last few projects. We'll be right back.
Boom, 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 boom.
Do.
And now is sponsored by DigiKey.
The Agilent Workstation Discovery 14. I shouldn't make fun of our sponsor stuff. I'm not doing that.
No, you too can have a 5 megabyte hard disk that is the size of your refrigerator.
Okay,
Absolutely.
So we'll go ahead and power through the last few. So Mark, you want to be up next for?
Sure.
Yeah. All right. Very good. We'll roll into you, then Vince, and then I've got a short one, and then we'll wrap up. All right. Here we go. Counting down. Okay, Mark. So let's figure out what's on your bench. I know you've had a secret project for some time, but surely there's other things that you're working on.
Yeah,
Did you call
yeah.
him Shirley?
I do have other things I'm working on, and don't call me Shirley. Yeah, so actually, really quickly, before I switch away from the secret squirrel, have all of our listeners registered to attend Baycon yet?
Not all of them.
Baycon, what is this you say, Mark?
Baycon is a presentation put on by the Baynet? I don't know what WW6BAY. What's it?
Amateur Radio Club. It's not that complicated.
Okay, what is that? What we're doing here? Anyway, so anybody who's wondering what Secret Squirrel is, you may want to go register to attend Baycon. Is all I'm saying.
And if you want to do that, you go to www.bay-net.org and you could register for free, or you can make a generous donation and leave it up to your conscience to decide.
And that'll be February 5th, all day Pacific time on YouTube, streaming to you.
And I will point out that there are multiple different Baycons, quote unquote, and you want to make sure to get the ham radio related one, not the sci-fi and fantasy one. Although that's also fun. Been to that one as well, but that's not the one I will be presenting at. So anyway, yeah, so I still have lots of Secret Squirrel stuff going on. I have progressed far enough that I have made the decision that I am definitely going to be attempting to turn this into my day job. So it is the new year. I am on next tax year, so I have started the process of spinning up the business, which is kind of the part that, I don't know, I'm not the expert at. Anyway, I've got a friend who's a corporate lawyer, and she's helping me file the paperwork with the state of California. So Halibut Electronics Incorporated will be a thing in a few weeks. And once I have my tax ID number, then I'll be able to go set up accounts and do all the, get the business license and do all the fun businessy things. So that's in process. I've been working on hardware that is prototype hardware. That is to say, it was intentionally designed big and spread out, and not the final design, just because I wanted something quick and easy to develop on. And so, last couple of weeks, I'm comfortable enough with the finality of the hardware design that I worked on putting it into its final configuration, and just 2 days ago I sent that order off to the board fab house. So I've got 5 prototype boards with all the not all the parts, but many of the parts put on them on their way to me, plus a front panel and 2 side panels for the Hammond extruded aluminum case that this is going to go into. So it'll be really fun to see the thing that I've had in my head for years actualized in a real chunk of hardware in its final form in my hands in a few weeks. I'm really looking forward to that.
And dare I say, it's going to be fun to see, a couple of dollar signs hitting your bank account as a result of all this effort too. So I'm really excited for you. You have no idea.
Yeah, me too. I also sent out one of the prototypes off to a beta tester. He's a listener of the show and a friend of mine. But I sent it off to him. It should arrive tomorrow. So we're recording this on Friday night, the 21st. UPS claims that it'll be delivered on the 22nd. So hopefully he'll be able to start playing with the thing and tell me all the things that's wrong with it. And friend of the show, Marcel, AI6MS. You may be familiar with him. He has been helping me out by letting me use his service monitor to test and measure a bunch of things. And another
fun
person,
times in the lab on the workbench, quite literally on the workbench with
literally on the
fellow
workbench.
ham radio workbench nut.
That's
It's
right.
Great.
That's right. Should we mention the other person who's been helping me out on this?
Sure, we got another ham, Justin Kenny, KJ6KST, who is my buddy from college, and he's been helping with some of the design as well.
Yeah.
He does some really good RF work and helped out. It does a lot of little prototype projects as well. Revo Proto is his online presence.
Yeah.
But very, very cool stuff and a lot of good detailed design work, a lot of optimization of filters and kind of working through very specific components that are difficult to deal with. That RF things behave differently. So your normal capacitors from different websites, you have to account for the board, you have to account for your trace lengths, you have to account for all these pieces when you're working at these frequencies. So it's been pretty fun, and Mark's learning a lot. His layout skills have improved dramatically with a couple design reviews. It's pretty amazing to watch that growth. So
I wanted to point that out specifically for Justin because he has not just been doing the work for me. The old adage, give a man a fire, he'll be warm for a night. Set a man on fire, he'll be warm for the rest of his life. Justin has been setting me on fire and teaching me how to do this, and it has been really helpful, and I just wanted to give him a shout out. So thank you, Justin, very much for the help. Yeah, and while I was placing an order for those boards, I also placed a second revision order for another product idea that I have. I can't remember whether I've talked about this one on the show. I think I have. In the QSO Today Ham Expo in fall of 2021, I gave a presentation on measuring common mode current chokes using a nano VNA, and I presented a test rig that you needed to build to be able to measure that using the nano VNA. The hard part's getting the signal on the outside of the shield, because normally coax wants to put the signal on the inside of the coax. And so you got to do some shenanigans to get the signal on the outside of the coax. And in that presentation, I showed a kind of a big plastic project box with connectors and coax and a switch and everything. Well, I put all of that on a circuit board with connectors on it, and this is the first revision of it. I made some tweaks. I also ordered the second revision of this, revision B, and I suspect that revision B is going to be the part that I turn into a kit and make available. So this may be the first Halibut Electronics kit that becomes available. This is not Secret Squirrel. This is a side thing that I did because it was quick and easy. This may be the first thing that Halibut Electronics releases, because I suspect this will be ready before Secret Squirrel will be.
That was the squirrel that distracted you from the secret squirrel.
This is the squirrel that distracted me from the public squirrel that distracted me from the secret squirrel. I've got plenty of other project ideas in mind that I'm like, nope, put it on the backlog, file a ticket for it. I'll get back to that later. I need to stay concentrated on this thing. So anyway, as for Thomas Martin says he wants one of these. Well, hang on. In probably a month, maybe two, somewhere in that time frame, these will be available. I know you already do, but follow me on Twitter. And I should announce that. Halibut Elec, HALIBUTELEC, is the Twitter handle for Halibut Electronics. I created a Twitter account for that before I did anything else, because of course I did. So if you're so inclined, go ahead and give that a follow. If you've ever unfollowed me because of all of the non-ham radio stuff that I post, and I do post a lot of it on Smitty Halibut, and you are interested in following along with my projects, my ham radio stuff, without all of that other stuff, Halibut Elec is the Twitter profile for you to follow. So go check that one out. Okay, so as far as Workbench stuff goes, Like I said, I haven't had time to do a lot of personal stuff, but I will give a shout out to W4IPA. I'm not even sure what his name is. I've just been working with him as W4IPA. But W4IPA reached out to me on, his Twitter profile does not list a name. All right, let's go. It's just W4IPA. He reached out to me on Twitter asking some questions about audio amplifiers. So he has a Kenwood 71A mobile rig and a Heil Pro 7 headset. The Heil has a dynamic mic. The Kenwood expects an electric mic. And those two don't work as well together, not directly. So he needed to design an amplifier for that. And so I kind of helped him out with that. And we iterated on the design a few times. And he posted a bunch of links. It's like, I found this circuit online and I found this other thing online. And I'm like, yep, if I were doing it, I would do it this way. And he kind of took all of the different pieces and put together his own design using the bits and bobs from all the different things that he had looked at and put it together. And that's really kind of the best way to do this, is you look at how other people are solving this problem, try and understand it, pick the parts of those that make sense for your given use case, put it together, try it, see how it works, change things as necessary, and keep going until you have something that works, and then, put it into a board design or whatever. So last I have seen from him, he had it working on a breadboard and had his Heil Pro 7 headset working into his Kenwood radio at acceptable volume levels, and was going to move on to designing a circuit board and getting that fabbed. So that's super exciting. It's not something I'm doing, but it's something that a listener is doing, and that I'm helping him with. But he's been kind of taking me along for the ride on that, and that was a lot of fun. That's it. That's all I got that I can talk about right now anyway.
And I know when you said I have a whole bunch of other ideas, I know you have a bunch of other ideas. If you only had more than 24 hours in the day.
Oh God. Yeah.
Truth. I think we all are afflicted with that problem. But
Yep.
I'm really excited for you to get the company up and off the ground and launched. That's very exciting.
Thank you. I spent last night putting together a bill of materials to build Secret Squirrel. I'll go ahead and announce the name. The name doesn't mean anything without knowing what it stands for. SOAR is what it's called.
Well, that helps a lot.
SOAR.
Oh, phew.
And so I started putting together a bill of materials for SOAR if I buy all the parts in quantity to make a batch of 50 of them, and a batch of 100 of them, and so on and so forth. And my BOM cost is going to be pretty good. Thank you, Raker. Raker says, good luck, Mark. So thank you very much for that. My BOM cost came in a little bit under what I was targeting. So I think I'm going to be able to sell this thing for a reasonable price and still make reasonable money out of it. I'm looking forward to it.
That's awesome. So the official public announcement of what the product is going to be at Baycon, right? That's the first time you're going to talk about it publicly?
That's the first time I'm going to be talking about it publicly, yeah.
And when is that again?
February 5th,
Very
2022.
good. Well trained.
Yeah.
Hey, Marcel, what time is it?
It's Baycon time. Yeah, we'll have all sorts of fun fundraising stuff hopefully figured out by then as well. But it should be a good time again. If you joined us last year for our first virtual Baycon, it was second virtual. I can't even keep track now. It was good fun. So definitely looking forward to a lot of great speakers this year.
By the way, I locked down our grand prize donation source. So once again, Digilent is going to donate Analog Discoveries for the grand prizes. So we'll have some pretty awesome prizes. And I know you and John are working on some other stuff, Marcel. So I think we'll have some pretty cool prizes to raffle off.
A 7S10P battery pack?
Yes.
You ask really nicely, Mark. Yeah.
All right. So Vince, what you got on the bench?
Well, I am I just want everybody to know that the squirrel is strong at Chevy E6LK, and I have way too many things on the go, and this never happens to anybody. So I'm going to list them. I have to read from the show notes. I'm going to list them in no particular order. There's a Pixie 40 meter kit. Thank you, my dear brother, for sending me that for Christmas. There's a K3NG keyer kit that's about the size of a small mint box that I ordered up out of Japan. There's a KPC3 that needs to be swapped into my WinLink Packet to Go kit. There's a 12 volt, 50 amp hour battery build project that's still sitting in parts that, needs some assembly. There's an FT857 that needs to have a high impedance pan adapter tap put into it from, I'll remember where it came from eventually. A gentleman in the States, but it's based on the UK design. I have a PA0 RDT mini whip that needs to get finished. I have a UHF multi-coupler to insert into my rack, but first I have to tune it. And then I have repairs. I have an MCHF. The other FT857 that I own, the rotary encoder, is going a little goofy, so I've got the spare parts. But now that I have the Hacko desoldering kit, that'll make that so much easier. The powered speaker in my shack that's attached to the Heil PRAS is buzzing, so I finally got the capacitors ordered for that, and I have a station grounding gremlin. I have way too much stuff on the go. But the cool thing is, my brother bought me for Christmas, I'm holding it upside down, of course, for the viewers, a tiny spectrum analyzer, a tiny SA. So here's a cool little piece of kit that it literally fits in the palm of my hand. And I haven't used it a lot yet, so I'm not going to talk about it in any depth whatsoever. It has 2 input ports on it. It does a nice spectrum analysis and lots of other cool stuff. It has a built-in battery. It has USB-C in it. I won't let the electrons fall out. Thank you, Raker. And it has really good, fast screen draw time on it. And you can, of course, hook it up to a computer to get some extended functionality out of it. How much have I done with this? Only slightly more than the rest of the list I just gave you, because I've been busy working on my Baycon presentation. So don't confuse Baycon with bacon, for those of you who are wondering. But wow, I got way too much to do, and I haven't done any of it because I've been dealing with other stuff because the squirrel is strong.
Man, you need a staff of people to work on some of that stuff.
I listed it all out tonight, if only for therapeutic value. But now, being the energy efficient person that I am, that's a double baffle gab for lazy. I'm going to take this part of the show notes out. Mark is laughing. I'm going to take this part of the show notes out, and I'm going to print it, and then I can stick it up on the wall, and then I can start crossing things off as I get them completed.
I have literally signed up on GitHub and made GitHub projects, and filed issues for all of the things that I need to do. Like I couldn't figure out how to make Jira.com or Atlassian Jira work without becoming a Jira admin, so I kind of gave up on that. But I am literally using project tracking tools, commercial project tracking tools, for me to remember what the hell I have to work on any given day.
Yep.
Yeah.
Yep. Indeed. And so I just remembered where that pan adapter tap comes from. The pan adapter taps that I have been putting into my radios come from David Callow, Kilo Delta 2 Charlie, KD2C.com. I'll put that in the show notes. I installed one of his pan adapter taps into my very lovely Kenwood TS130S, along with his great direction. So I tapped the RF, which gave me effectively split VFO on that radio, because that's a single VFO radio with no split capability. It was a lovely mod that I did to that radio, and I've documented that on my website. I've put one into my FT450 as well, which is great. So now my SDR play runs out of it. And then the last KD2C tap is going to go into my GoKit FT857. So anyway, that's what's on. That's what's almost getting onto my bench. That's embarrassing. Hey, George, what about yours?
Well, thanks, Vince. It sounds like you have an overwhelming number of projects. I think I have the same number, but I can't remember more than 3 of them. So I'm sure there's a long list. So this project I'll show on the video is a new board, or actually a board set that I'm doing. It's a Benchduino Nano. So a couple of years ago, I made a microcontroller development board called the Benchduino, and you could use it to develop code for an Arduino or a Raspberry Pi or a PIC, whatever processor module you want to plug into it. And I wanted to make a sort of a smaller, lighter weight version of that, both for myself for projects, but also for folks who want to learn how to program Arduinos. And so I made a one that's purpose built around the Arduino Nano. The Nano is a pretty popular version of the Arduino, and there's Chinese clones and there's the original ones. Anyway, so that's that's done. I have to send off the boards to the fab to get the boards back, but it's got an LCD. It's got LEDs, it's got buttons, it's got a rotary encoder, it's got a potentiometer, it's got some temperature sensors, it's got a relay, it's got a serial port. So it's got a kind of a garden variety of peripherals that you find on a lot of projects. Since the whole point of this thing is that if you want to build a simple project, rather than to kind of jerry rig and hook up all the wiring and the stuff, you could just write the code right on the board. And all of those peripherals are pre-wired to various pins on the processor, but they all go through a jumper block. And so if you don't want like the relay in your project, you just pull out the jumper and it disconnects the relay. And you could do that with all of the pins. And so it frees up all the pins. The other thing that you could do is you can plug a companion board onto the side, an expansion board, and make custom ones for different projects. And I've got 3 or 4 different project boards that I want to make for it. But I was talking to a friend of mine this week, Rick, KC6UFT, and he pinged me because he was working on a battery monitoring conditioning project. And so we got to talking about it, and we eventually zeroed in on the idea that we need to take his project and make it into a companion board that plugs into this thing. So what Rick is working on is a 18650 battery tester. And so the idea is to take the single 18650 cell and you plug it into its little socket, its little battery socket. 18650s are like a big AA battery, but they're lithium ion rechargeables. So anyway, you plug the battery into the socket, and then the Arduino, there's some relays and some load resistors, and the Arduino will put different loads on the battery, and it'll measure the current and voltage, and it'll derive what the internal resistance of the battery is. And so from that, apparently you can figure out like how good is the battery? Is it like a brand new one? Is it kind of an old one? So maybe it gives you a resistance measurement, or maybe it even dumbs it down to like, a green LED, a yellow LED, and a red LED for, good, okay, and bad. So you can test all your 18650 batteries. So anyway, we took Rick's circuit and we laid out a circuit board, and it will plug right into the side of the Arduino, or the Benchduino board. So the control panel will be on this board, and then all the loads and everything will be on the companion board. So that'll be kind of a fun project. But you can also plug in other daughter cards to the side, like an IO expander board or a serial interface, or a variety of different gadgets. So anyway, that's probably going to turn into a Workbench circuit board set that we'll put together. I think we're probably only a month away from that. So more on that as we get closer to it. But it's really been a lot of fun. I've been using these Arduino Nanos for a while, and the big advantage of these processors is there's more flash, so you can put a bigger program in it. And they're fairly small footprint. The funny thing is, one of my all-time absolute favorite YouTubers is Andreas Spies, HB9. I forget, LA. Andreas was on the show. He's the guy with the Swiss accent, and I absolutely love his videos. And so he was on about 3 or 4 months ago, and he did a video on all of this new crop of Arduinos. And his punchline was, I don't know why in the world anybody would ever use that nano every, which is the one I'm using. So anyway, for me, it's actually a great, I think it's a really great choice. So that's what's on the workbench amongst a bunch of other stuff. And hopefully we'll get that stuff done pretty soon. We had one question that I noticed in the on the YouTube feed. This is for Doug.
Oh.
So Doug, there's a microwave question for you. And let's see, the question is, how can I tell, where is it? How can I tell, determine the polarization, horizontal or vertical, of a rectangular waveguide?
Well, rectangular waveguides are not square, they're rectangular. And one way is horizontal, one way is vertical. And I believe if the long side is horizontal, that's vertical polarization. Dennis will say, is that horizontal, up and down? It's not an often asked question because you put your antenna.
Yeah.
I
like stump the masters.
Thinking about it. Yeah. Horizontal polarization would be with the waveguide with the long wave vertical. That would give you horizontal polarization. Yeah, and
correct.
Vertical polarization, the wide side would be horizontal.
Okay, so if you look at the waveguide and it's rectangular, and if it's flat, not vertical, if it's like horizontally oriented, then it's horizontally polarized.
Yes, write that down. A rectangular waveguide is not square.
Well, I'm glad you geniuses figured that out.
Thanks, Wayne.
I was just reassuring them.
Oh, yeah, Wayne's very helpful that way.
Yeah, that's awesome.
Actually, I have some WR8 meant for 110 gigahertz, and you can't even see it. And you're not supposed to talk anywhere close to it because the water vapor that comes out of your mouth will lodge in the waveguide and cause loss. 8/100ths of an inch across the long way.
All right.
There we go. And for our listeners at home who were wondering what just happened there, Doug asked Dennis a question, and there were wild gesticulations of flat hands and arms waving all through the air, and the hands were moving in a horizontal fashion and a vertical fashion at the same time. It was that was incredibly instructional for this homeboy who doesn't talk about 440 megahertz.
Would you like me to go get a piece of waveguide and show
Yes,
you?
actually, we would.
I'll be right back.
I'm glad that would happen.
Would WR90 be okay?
That'd be
Yes.
lovely.
That would be
All right.
fine.
So we'll have to do the waveguide checkout here in a minute, and I think we'll probably wrap after that. Dennis, go ahead.
I had a comment. I was just chuckling about it, talking about this room with all the big radios. Doug talks about test equipment, and one of the things he talks about is the fact that these things like the Nano VNA and the Nano SA and all these really great little tools, you take the tool to the project rather than the project to the tool, right? So what I've got sitting in the next room in here it's in keeping with the giant radios, is a Hewlett-Packard 8566 spectrum analyzer that weighs about 150 pounds, and it's on a cart to move it around. And I was just thinking, it's quite in keeping with everything else in this room.
So it's a little hard to bring that up to a radio site, Dennis, then, right?
Well, it depends on the size. Depends on the size of the tires and the suspension on the cart, I would think.
Exactly. Is it towable? Yeah, can you put it up onto your Jeep? Yeah.
It's not. It's luggable.
You bring that along with you to your POTO activation that you're bringing the Collins gear to.
There you go.
Yeah.
Do you know? Funny story. I was mentioning the 20V, the kilowatt 20V transmitters, right? There's a group somewhere out east that's been doing field day with a 20V transmitter in the back of a pickup truck. So they haul the transmitter out in the field and run it on field day. And that's just nuts.
Okay, Doug, show us the plumbing you've got there.
Okay,
And describe as you go.
This is WR90 for 10 gigahertz and that region, and it's 9/10 of an inch across, I believe. And this would be what, Dennis, vertical?
That would be vertical.
Oh, I thought we just determined the opposite.
That's horizontal polarization like that.
Okay, and so for our listeners, first, Doug has held the item sideways to me, sideways, so that the short edge is up and down, and he's rotated it 90 degrees a second later so that the long edge is up and down, and the answer was vertical and horizontal. That is not the answer that I am expecting.
Yeah,
it's
it's
the
I'm
opposite of what
expecting
it
the
looks like.
reverse.
very counterintuitive. It's exactly the opposite of what you'd expect it to be.
So
Okay,
it's
so when the
okay.
slot is up and
polarization is at right angles to the long dimension of your waveguide.
That's right. It's
Okay.
Yeah, same with slot antennas, like the dish antenna that I presented about last year.
Oh, that's interesting, Marcel. So that the slot antenna, when you cut a horizontal slot,
Hmm.
it's vertically polarized.
Correct.
Oh, okay. Well, there's a whole nother show topic.
There you go.
Yeah. Thank you, Doug. That's great. Now, what frequency is that good at?
7 to 12 gigahertz, and it's a switch. It's single pole, double throw switch. It's I'll give it in the middle of the thing, and let's see if I can get it.
It sounds like that switch needs a little WD-40. Not that I'd ever use WD-40. I'd use deoxit or something else. But
Yeah, we try not to do that.
yeah, okay.
This has a central round part, and it has it isn't as self-evident because the radio waves will leak around the round part when you switch it.
In the middle.
Yeah, and then you have to add little channels in it to trap the waves. It's
Wow.
we did it.
And this looks like a plumbing fixture to me.
Yeah, like a ball valve.
A
That's
ball
right.
valve. Yeah, good.
A square ball
Two
valve.
kinds, the old kind of microwave stuff is all plumbing, as we call it, and I have radios like that, and the rest of it's all strip line.
I don't know if you mentioned it, Doug, but that's called a baseball switch. Does the knob have has the diagram on it, or is
This
it's
is a
not
single pole. This is a single pole double. No, it is a base. I'm sorry, it is a baseball. There's the other
it's a
side.
double pull, double throw? It's a transfer switch, is what it is. But we call them baseball.
Sure,
switches.
okay.
Because if you look at, I used to work in satellite business. Yeah, exactly. That you got it, Mark. It looks just like the stitches on a baseball. And
On the inside.
I worked in the satellite business on ground stations, and we had those things all over the place to
Here's
switch.
the markings. It would normally be a baseball. You have two arrows like that. Show you
Yeah.
what sides were connected, and this one doesn't. It
So
never
for the
had-
audio listeners, picture north, south, east, and west on this. You got a block of metal with waveguide ports on the four sides. So the north, south, east, and west, and like this rotatable cylinder in the middle of this block. And in one position, the rotatable cylinder will connect north to east and south to west.
exactly.
But when you rotate the inner part 90 degrees, it connects north to west and south to east. And so if you kind of view these the directions that the signals are going as lines, they look like the stitching on a baseball, where you've got the kind of the two lines going, or like two curves butting up against each other.
And God help you if you get it wrong when you hook it up on your transmitter receiver, because you'll feed the transmitter directly into the receiver front end.
Oh yeah,
Is that a bad thing?
Yeah.
yes.
You won't hear anything. You won't hear a thing.
RF
Like,
is magic
ever again.
and microwave is black
Black
magic.
magic.
Yes, Thomas Martin, that is very true.
Nah, it's all physics.
Remember this, Doug?
Oh
What do you
yeah,
know there, Dennis?
I know that one.
That's a
That's
dish.
a shepherd's crook feed. But you notice that the this thing, when it's mounted like this, it's got vertical polarization. So you'd want to use it like this to have vertical or horizontal polarization. You want to use horizontal polarization when we do weak signal, less absorption.
Sorry, Dennis, what did you call that? A something hook something?
It's a shepherd's crook. You see what it looks like.
A shepherd's crook feed. So it's a relatively flat dish with an LNA arm on it. I'd call it an LNA arm, except
Well-
it looks kind of like a question mark.
It's a feed. This is your feed.
That's the feed.
It looks
Okay.
like a question mark. You're right. But that's the feed. And it's called a shepherd's crook feed.
And
there's
so,
a little tiny feed horn right there that you can't quite see. But that's
right at the tip of it. And well, and that all makes perfect sense.
a little bit of gain.
But now you guys are messing with me. I'm pretty convinced you're messing with me at this point. Because Dennis, you held this thing and the question mark was standing straight up and down, and you said that's vertically polarized, and then you turned it on its axis sidewise so that the question mark was laying sideways, and then you said it was horizontally polarized. But that is the exact opposite of what I just heard a few minutes ago. I swear you guys are messing with me.
This is why microwave is magical, because the physics keep changing.
Yeah. No. He's got it right, because
This is horizontal. That's the black edge is positioned.
Okay. Well,
I have to look at the wave guide, not the
Yes.
question mark.
Yes.
Yeah, you got to look at the wave guide.
Yeah.
Okay.
And Dennis, so on that dish, there are two big stenciled words "hand" on opposite sides. Is that where you're supposed to put your hands to get extra gain?
You know,
or what's the purpose of that?
I always wondered what that was for.
When you're on a mountaintop, it gets really cold, and so that's where you put your fingers to keep them warm.
That's what I figured. It's frostbite prevention. Yep.
There's a lot of stuff we have we don't ask where it came from. You may not want to know where it came from. And
I suspect
Dennis lives next to a China Lake Naval Weapons Center, so things fall off the range now and again.
I suspect that this came from. I suspect this came from China Lake. It was one of the things from Chuck's estate.
Chuck was a guy they called. He didn't have a real job title. They just, when there was a problem, they called Chuck, and he came and fixed it. And he can't tell us what he fixed ever.
You calling in the wolf?
But he fixed it.
Chuck was great. He is quite a character.
He was a ham and a gentleman through and through.
All right. Well, I think we've kind of
fascinating.
I think we've hit our time limit here. So I think we're going to go ahead and wrap things up. Any last minute words of wisdom or project comments from anybody before we wrap up?
It's always fun.
Always fun.
Great.
I hope to see everybody at BayCon 2022 in support of Whiskey 6 Bravo Alpha Yankee, Pukie and WW6 BAY, and BayCon 2022. You will get to the right place.
Thank you, Vince. That's great. Marcel, any last minute words from you?
Yeah, the other thing I would add is, with COVID, it's been going on a lot longer than a lot of people had originally hoped for, and amateur radio remote exams are still a thing. This has been my hobby since the start of COVID. I joined the team that kind of helped develop a lot of the examination tools and improve the software, and we just released another big version a couple weeks ago here. But if you're looking to get your amateur radio license, or if you're looking to upgrade your amateur radio license in the US or even in the UK and Australia as well, a bunch of countries are now doing online exams. Hamstudy.org is the one that I'm involved with, and did about 20% of the exams during the first year of COVID around the United States. So pretty cool. And there are exams multiple times a day. So if someone tells you can't get your license because there's no exams near you, it's a lie. You can go online, and if you watch this live stream, you probably have the ability to do that as well. So I definitely want to give that plug for anyone, new hams, old hams, you name it.
In the early 80s, I helped write the modern exams. And my orientation, as I was told, and which I did because my background is also education, that we wanted to write an exam that people could understand and pass. And so we were assiduous about how we wrote the exams so that you guys could become radio hams, not to cheat or to make it too simple or brainless, but to make it relevant and useful. And it's still that way.
Yeah, totally agree.
Excellent. Well, and that's wonderful work. I mean, I think it's so great. You and Vince, you guys just do an amazing job of trying to encourage people to get licensed and actually go out and make that happen. So that's a great work.
And the other thing, George, is I've been a ham for close to 60 years, and I'm not done yet. And we should go around and say, this is not just a fly-by-night hobby for people, or something you do and you finally do a project and that's the end of it and you walk up and do something else. This is something that's kept us excited over decades. George, how long have you been a ham?
50 years, actually, last year.
Vince, how long about you?
I am coming up on 20 years, but if we count when I wanted to be a ham, 1969, from 1969, do the math. I can't do it that fast.
50 years.
Yeah.
Marcel, how long have you been a ham?
2008, so that's putting me at almost 14 years now. So
that's pretty good. And Dennis, how about you?
52 years.
And Mark?
Holy moly.
I'm only 47 years old, but I've been a ham for
62 years.
62 years, yeah. No, 91 or 92. 92 is when I got my license. So 30 years now.
30. Yeah.
It's we have among hams we have a very small dropout rate, and we frequently have people in their later years still as hams. So it's not an interest that people generally throw away. It's something that people keep for a long time.
I'm going to throw it away as a hobby because it's become my day job, but I'll try not to make that happen.
Well, yes.
At 47, things are going to change, and you'll turn at some point and say, I always wish I got on 40 meter CW, and you go back into it.
Yeah.
I am no longer surprised by the number of exams I give to people that are above 80 years of age.
Mm-hmm.
And Marcel is shaking his head. Yes.
Awesome.
That's awesome.
80 and 8 years of age. We see both ends of the spectrum. It's
exactly.
pretty amazing. Yeah.
Doug, I want to add a quick note here to your comment about being a lifelong thing, and you'll always be learning. If you want something where you're always learning, this would be the place to be, because even after 50 years for myself, there's a lot I don't know, and I'm constantly learning stuff or relearning stuff. And I think the other big bonus really that a lot of people come to realize once they get into it is what we've got here. We get the opportunity to spend time with people who we really loves being with and really cherish that time. And I think we all, we're very appreciative of all the great friends we've made over the many years. And so it's just, it's a hobby that gives on many levels. So thank you all for being here today. It's really been a pleasure. And we just hit the tip of the iceberg on so many exciting things. So I think we'll do a wrap at this point. So thanks very much. For those of you watching on the live stream, thank you so much for joining us. It was a real last minute thing that we posted as we went live. So you guys are really like right there on the spot. You had no idea it was coming until we announced it.
And 3 dozen crazy people followed us along and shot us some excellent questions. And we had some great interactivity. So, hey, thanks.
Live studio audience.
Yeah, that was great. We'll do it again. So, guys, have a great night. And for all the listeners and the viewers on the live stream, 73, everybody.
73.
73.
Thank you. This has been great. See you again.
Be good humans.